Hello and welcome, I'm your CodeMonkey, and here is a free complete course on making a game from start to finish. If you've always wanted to learn how to make a game, or if you already know the basics but want to see how to organize a more complex project, then this video is for you. It's perfect for both beginners and more intermediate users. This is a completely free course video, but it has the same level of quality as my paid courses or my Steam games. You can download the project files to follow along or inspect the final game. You can even play the final game directly on Steam. We're going to start completely from scratch and build a really awesome game with tons of systems and mechanics. Building this design requires working with lots of Unity and C# features, so this is a really awesome project for you to learn. After following this course and learning all of these techniques, you will be able to build all kinds of games in all kinds of genres. This is going to involve learning about the basics of Unity and C#, learning how to make a character controller, physics raycasts, learn all about C# interface and events, using scriptable objects, handling UI, the new input system, and lots more. Very importantly, everything that we're going to do here is going to be focused on writing good, easy to understand, clean code. Meaning that I will not be teaching you bad practices that some beginner tutorials teach. The code that we're going to write here is production quality code. This is not a throwaway demo. The quality of the code and the structure of the game that we're going to build is on the same level of quality as my own Steam games. As you can see from the video link, this is indeed a complete, very thorough course, so don't try to watch this whole thing in one sitting. Take your time, take it slow, and just focus on learning. There are chapters for every single lecture in the video. Here's a quick overview of the entire course, all the steps that we're going to take to reach the final polished game. So first of all, we're going to start completely from scratch by selecting a Unity version and creating a brand new project. With that new project, we will then learn all about the basics of the Unity interface and set up a layout. Then the other important part is Visual Studio, which is where we're going to be writing all of our code. After that comes an extremely important lecture all about coding style and naming rules. Like I said, the code in this course is on the same level of quality as my Steam games, so having proper naming rules and good code style is paramount. Next, we're going to download and import all the assets that we're going to use in the course. Everything is included so you can follow along with every step of the way. With the assets imported, we're going to set up some quick post-processing just to make the game look good. Then for our first piece of logic, we're going to make a simple character controller. With that logic working, we will then implement a proper character visual with the included assets. Next, we're going to learn the basics of animation and the animator component. And with that, we're going to make our player really come alive with some simple but really nice animations. Then we're going to install the Cinemachine package. This isn't actually used too much in this course, but I still wanted to include it because it is such a useful tool, so I do want you to know about it. After that comes another extremely important lecture with regards to writing some good clean code. We're going to do a nice refactor to replace the legacy input manager with the brand new input system. Learning how to refactor is an extremely important and very valuable skill that will massively improve the quality of your code. With that done, we're going to implement some nice collision detection to make sure our character doesn't walk through walls. Next, we're going to create the very first kitchen counter and make a script to handle how to interact with it. Then we're going to learn all about C# events and create a proper interact input. Next, we're going to build a selected counter visual, which will require us to learn about the extremely useful singleton pattern. With the counters working, we're going to start working on the kitchen objects themselves. So these are going to be the ingredients and the plates. We're going to use scriptable objects to define all of the types. Then a very important part of our design is each kitchen object will have to be placed somewhere, so we're going to take some time to really think about the best way to achieve that, all while writing some good clean code. Next, we're going to enable the player to pick up an object. In doing so, we're going to learn about C# interfaces. Then we're going to make a container counter. This is from where we can spawn new objects. With that, we will enable the player to pick up objects and drop them anywhere where there's space. Then we're going to make the cutting counter. This one enables the player to cut an ingredient into slices. So to do that, we're going to make an alternate interact action. And for handling the cutting, we're going to once again use scriptable objects to define a proper cutting recipe. Then we're going to learn about a really awesome Unity feature, World Canvases, and use that to display a nice progress bar for our cutting progress. After that is a quick lecture, just going to make a very useful generic script to make any object look at the camera. Next, for another counter, we're going to build a trash bin. This is where the player can drop objects to destroy them. Then the stove counter. This one is going to be quite a bit complex. We're going to create recipes for cooking and for burning. We're going to learn how to make a basic state machine and handle timers. Next, we're going to make the plates counter. This is a simple counter that just spawns a bunch of plates. After that, we're going to make some custom logic on the plate to be able to hold other objects. With that logic working, we're going to build a complete visual for all the objects that can exist on the plate. Then make a nice UI element on the plate itself to showcase the icons of what exactly is on that plate. Afterwards, we're going to make the very last counter, the delivery counter. This is where we drop the completed plates. And in this lecture, we're also going to learn about the Unity shader graph and make a quick, simple custom shader. Then we're going to build the delivery manager class that generates the recipes that the customers are requesting. Next, we're going to build a UI to showcase the waiting recipes. After that comes something pretty crucial. We're going to add some music and then add some sound effects for all kinds of game actions. With that, the game will be almost done. So next, we're going to build a proper game start and a game end. Then make a simple main menu and handle scene loading. After that, handle creating a basic pause window. Then make an options menu, enable the player to modify the audio levels and rebind keys. After that, we're going to enable menu navigation with a controller. And in the end, as usual, comes the polish stage. So we're going to add all kinds of small tweaks and effects to make the game feel really great. Like I've said many times, polish is what separates good games from great games. After all of that, we will have our final completed project. So as you can see, you will learn about tons of topics by following this course. Also, let me point out, one of the reasons why I chose this specific design is because my next free course will be on taking the game that we're going to build here and make it multiplayer. So if you've ever wanted to make multiplayer games, then that course will be excellent for you. Definitely take your time following this course. The multiplayer free course should hopefully be out next month, or if you're watching this in the future, check the links in the description. Although that multiplayer video won't be starting from where this course ends, so definitely make sure you watch this one. Now, if you're new to the channel, then welcome, and here's a bit about me and my credentials, or why you should listen to what I have to teach. My name is Hugo, and I've been running this CodeMonkey YouTube channel for 5 years now. In total, almost 700 videos on all kinds of topics, including tons of tutorials sharing my knowledge to help you on your game dev journey. I'm also a professional indie game developer, making games for over 10 years with 8 successful games published on Steam, so what I'm teaching here is based on a lot of years of experience making a lot of games. Just like with my paid courses, I'm always going to be in the comments answering questions, so if you get stuck at a particular point or need extra clarification on something, go ahead, post a comment and I'll do my best to help. Do make sure you include a timestamp of what you're referring to. I will also be updating the pinned comment with any frequently asked questions that I see, so actually right now go ahead, pause the video and scroll down a bit just to look at that comment. Since on YouTube I cannot update the video after it's published, I will be updating that comment over the next months and years with anything that comes up. Also, I've been running this channel for 5 years, and in that time I've made almost 700 videos, so there's lots of topics that I've covered separately in more detail. All of those videos are linked in the description. Throughout this course, I will be focused on building this specific game using whatever it takes to build it, meaning, for example, when we get to using C# events, I will teach the basics about how they work in order to achieve what we want to build, but if you then want to learn about C# events in more detail, definitely go watch the dedicated video. And I also made a page on my website for this course. It contains a link to download all of the project assets. You can also download the complete project files for every single lecture. So if you get stuck at any point, you can download the code at that lecture and compare with your own. There's also references to all of the videos, and I will also be including frequently asked questions for each lecture. So definitely keep that page open in a second tab as you follow along this course. Now, this free course took a ton of work to make, so I really hope you find this video helpful. Go ahead and hit the like button if it helps you. It's a small thing, but it generally does help this video on the YouTube algorithm. Making this course was a ton of work, and by making it completely free, it means it will obviously never make as much money as if I had just made this a paid course. I'm perfectly okay with that decision, with the hopes that by making it free, it will reach and help many more people. I'm also a big believer that education should be free, so if you can't afford one of my paid courses, like if you're just a kid or going through a rough time, I still want you to have access to high quality education so you can achieve your game dev dreams. One easy way you can help me for free is simply by liking this video, subscribing to the channel, and just watching this course. That will hopefully help push this video on the YouTube algorithm and help it reach many more people. Another free way to support what I do is I'm currently working on my next Steam game called Total World Liberation. You can wishlist the game on Steam. Wishlists matter a lot for Steam visibility, so just by doing that you will be helping me. And just in case you can't afford it, and you find this free course useful, you can also support what I do in a few other ways. I spent a bunch of money making this course. I hired an artist for the 3D assets so that I had the rights to distribute them so that you can download and follow along. Same thing for the music and sound effects, the logo, and the cost to upload the game to Steam. So I would like to at least not lose money on this project. Hopefully there's enough of you who can afford to help me so that I can at least break even. And for one way you can support is I added this exact same course on my website as a regular paid course. Although I want to be very clear, there's absolutely no difference between this free video and the paid course. There is absolutely nothing behind any kind of paywall. All of the lectures are free, all of the asks are free, everything is free. You don't have to pay for anything if you can't afford it or you just don't want to. The paid version is essentially a donation. The only difference is this free YouTube video has regular YouTube ads, whereas the paid version on the website doesn't have any ads. That's it, that's the only thing. So the only reason why I made that paid version is just in case some of you can't afford it and you want to support what I do and want to help me break even on this project. But again, only do that if you can afford it. If you can't, that's perfectly fine. I hope you'll learn a ton from watching and following this free course. Beyond that, if you follow this course and you enjoy my teaching style, perhaps look into my other courses. If you like this video, then I think you will really like my turn-based strategy course. That is the perfect course to follow up on this one. It dives even deeper into some of the concepts used here, and it will help you make the jump from beginner to advanced. And since you're interested in Unity, I think my Ultimate Unity Overview course would also be very useful to you. Each lecture on that course is focused on teaching one Unity tool or feature. There's already over 50 lectures, including plenty of small but very important things that you just wouldn't see in a regular YouTube video. If you're interested in visual scripting, I have a course on making 3 unique games entirely with visual scripting and no code at all. Or if you prefer code, you can learn how to build a nice Builder Defender game. So if you enjoy my teaching style in this free course, then check out my other ones. Then of course YouTube has channel memberships and super thanks, so you can use those if you want. I also have my Patreon if you prefer that. And in a lot of my videos I have some affiliate links. If you ever pick up anything through those, I get a nice commission. And I also have some of my own assets on the Unity Asset Store. So if you enjoy this free course and you want to support what I do, there's plenty of ways. But again, don't feel obligated. If you can't afford it or you just don't want to, that's perfectly fine. I hope you'll learn a ton from watching and following this free course. Alright, so that's enough talk of that for now. Before we begin building the game from scratch, let's inspect the final polished game that we're going to build. So let's see that in the next lecture. Hello and welcome, I'm your CodeMonkey. Here let's take a look at the final game that we're going to build. So we start off on a simple but really nice main menu. So we've got a nice visual, a nice logo, and a bunch of useful buttons. Then of course the game has a nice loading system, so when I click on play, it's going to load into a loading scene and then finally into the final game scene. So let's go ahead and play. And yep, there we go, here we do see the game scene, and right away we see a nice tutorial window. So it's telling us how to play the game, so the basic interactions, and then over here the controls. Importantly, these are all rebindable, so over here this element is all dynamic. Then we can look at this tutorial for as long as we want, and we are waiting for the interact to continue. There's also a really nice song playing in the background, so the game has music. Now we can look at this tutorial for as long as we want, and when we're ready we can interact to continue. And as soon as we do, yep, there you go, we've got a nice countdown, some nice animations, a nice sound effect, and there you go, now we are playing. Okay, so here I am controlling a nice character. I can move in any direction. There is collision detection, so obviously I cannot go inside solid objects. So I can walk around, and for the goal of the game, over here on the left side we've got recipes that the customers are waiting for. So for example, one customer wants a simple burger. So for that, we gotta need to pick up a nice bun, so let's pick it up. Then the burger obviously requires a meat patty, so let's go ahead, we can pick one up from here, but this one is an uncooked meat patty, so we need to drop it over here on the stove. And there you go, it starts cooking. We've got a nice timer, we've got a nice world bar UI. And there you go, it keeps counting, and we've got some nice particles, some nice visuals, and over there even a nice indicator telling us the meat is about to burn. And there you go, the meat has burned. So now I can pick this up, and I'm holding some burnt meat, so the customer probably doesn't want to eat this. So we can go over here to the trash in order to trash it. Let's try doing another one and do it properly. So let's wait for it to cook. Pick up a plate so we can pick it up directly onto the plate. There you go, the meat is cooked, so let's pick it up. Then go pick up some bread, and there you go, here we have our complete recipe. So let's go into the delivery counter, deliver it, and there you go, a nice delivery success. Alright, awesome, we've just delivered our first recipe. So then someone else wants a salad, so let's go ahead and pick up a tomato. Here we have a big uncut tomato, so let's drop it onto a cutting board. And now we can interact with it, so we can interact with a secondary interaction key. And by interacting, we cut the tomato, so it takes a few cuts, and there you go, it slices, and it's sliced into tomato slices. So let's do the same thing for the cabbage. here we are holding a regular cabbage, then slice it, and this one actually takes a bunch more, and there you go, got both slices. Okay, great. So now let's pick up the plate, pick up both slices, and deliver to the customer, and there you go, got a nice success. Alright, awesome. And of course, we have a correct identification of if we have a correct recipe or not. So if I just pick up an empty plate and deliver it, there you go, we got a failed delivery because nobody wants just an empty plate. Alright, so here you can already see quite a lot of interactions, quite a lot of systems at work. So the character has a nice character controller, it has physics interaction, you can see how it identifies the counter that is in front of the character. I can press a button to interact with the counter, and interacting with different counters does different things. So if I interact with a clear counter, I can pick up or drop things. Over here I can pick up and drop it. With an alternate interaction, I can do the second action. Then there's the stove machine, so that one has a nice state machine, so it counts up. Over here we've got some nice particles, we've got a nice bloom, so all the visuals look really great, so we've got some post-processing. We have a bunch of UI elements directly on the world, and outside of here we've got some regular UI elements. So we've got the recipes with dynamic icons for all of them. We've got a timer over there on the top right corner showing how long we have to deliver all our recipes. And on the kitchen counter we're also using a custom shader, so this was built using ShaderGraph. So as you can see, lots of interlocked systems. Then the game also has, of course, the basics that any game should have. So I can pause the game, and there you go, we've got a nice pause menu. So we can resume to go back, or pause it again. And of course, while paused, everything is paused, so that's great. We can go back into the main menu, or we can go into options. And over here we can play around the sound effects volume, the music volume. We've got all of our controls. Importantly, these are the controls for the keyboard and also the gamepad. So the game can be played with any gamepad, so it can be an Xbox controller, PlayStation, Switch controller, doesn't matter, all of them work. And we can also rebind all of these keys, both the keys as well as the gamepad inputs. So let's go ahead and deliver a cheeseburger, so here's some burnt meat, so let's toss this. Then pick up some more meat, pick up a plate, here we've got some cheese, we've got some bread, pick up the meat, and deliver it. Alright, awesome! And of course, finally at the end, when our timer is elapsed, here we have a nice game over window showing how many recipes we delivered. Alright, so this is the final game that we're going to build. As you can see, it involves lots of interesting interactions which require learning lots of different skills. We're going to be using C# interfaces, C# events, the new input system, shader graphs, scriptable objects. We're going to learn about C# events, make a character controller, handle collisions, and so on. Like I said, one thing that we're going to focus heavily throughout the making of this game is on writing good, clean code, meaning that the final game that we're going to build will be very easy to expand upon. Thanks to how all the code is very clean, it will be very easy to add more recipes, maybe more counters with more actions, maybe things like perhaps washing dishes, adding an oven, and so on. Or really, you could make something completely different. This game is all about character and interactions, so that could be whatever you want. You could take this as a base and build some kind of sci-fi game, something like Among Us or FTL. You could make a survival crafting game like Rust or Minecraft or Don't Starve. Really, by learning how to build this game, by the end you will have gained the knowledge required to build all kinds of unique and interesting games. Alright, so now that we've seen the final game, let's actually build it. Just before we do, let's get a quick refresher of the absolute basics you should know in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to just get a quick refresher of the absolute basics you should know in order to be able to follow everything in this course. Okay, so like I said, this free course is targeted at both beginners and more intermediate users. In order to start following the course, you really only need to know the absolute basics. I've made 3 useful videos with all of the basic knowledge required to follow this course. Watch the video on how to download, install, and set up Unity, then the quick Unity basics, and the C# basics. Those 3 quick videos contain all of the absolute basic knowledge you need. So if you're a complete beginner, go ahead, pause this video and go quickly watch those. And even if you're already somewhat familiar with Unity, still go ahead and give those videos a watch, perhaps in a faster speed, just so you know everything that this course assumes that you know. Here I will assume that you know the basics covered in those videos, like what is a game object, what is a transform, what is a monobehavior, how scripts have a start and update, and some C# basics. As long as you know those absolute basics, you should be able to follow everything in this course. I will teach everything above the absolute basics. And if you are a more advanced user, definitely keep watching. The beginning of this course might not have much that is new to you, but as we build the game and start using more advanced tools like scriptable objects, C# events, and interfaces, refactoring code and focusing on project architecture and writing some good clean code, if you are not a complete beginner, you will still learn quite a lot from seeing how this project is built. And again, like I said, I answer comments every single day, so any questions you have, just post them there and I'll do my best to help. This course is split into lectures. They are all as chapters on the video so you can navigate around. Let me also take this time to point out that you are not expected to follow this course in one sitting. Go ahead and take your time, focus on actually learning. Remember, that's the only goal. You're not competing with anyone, you're gaining knowledge just for yourself. So take as much time as you need, rewatch some lectures if you feel you didn't fully get it, or just ask some questions. Whatever you do, take your time and just focus on actually learning. So again, if you haven't done so, go ahead, pause this video and go watch those 3 basics videos. With that, we're going to have everything we need to get started. We're going to start completely from scratch, so let's begin creating a brand new project in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to begin actually building our game. So let's create a completely empty project and start building it all from scratch. Okay, so the first thing that we need is to install Unity. Now I covered this in detail in that other basics video, so here I will assume that you already have Unity Hub installed. The first decision we really need to make is choosing a Unity version. So on Unity Hub, you go into Installs and install an editor. And now Unity recommends that you use the LTS version or long-term support. You should be using that one in most cases. It's what it installs by default, which as of the time of this recording, the latest LTS one is 2021.3. However, I want this video to stay up to date for as long as possible, so for making this game, I will actually be using version 2022.2. If you're watching this video right as it came out, then download this version. And if you're watching this months in the future, after version 22 LTS is out, then you can use that one. It won't probably be the exact same thing as version 22.2, so you should be able to follow everything exactly. For any changes, I will point them out in the updated pinned comment. And if you're watching this years in the future and there's an even newer LTS version, I would still recommend you follow using the 22 LTS. Don't worry about using a quote-unquote older version. Everything you'll learn here in this version will still be applicable even 10 years from now. So like I said, I'm going to be installing this one. And in terms of modules, it doesn't really need anything. I already have Visual Studio Community installed, and all of the other ones are unticked, so install. Okay, so the version is installed. Now let's create a new project. Let's go into the Projects tab. Then create a new project. And now first up here, make sure to select the right version. So again, I'm going to be using 22.2. Then for the templates, this has mainly to do with the Unity render pipelines. Now, if you're a beginner, don't worry about that too much. Just go ahead and select the 3D URP template. So scroll down, this one right here, 3D URP. Make sure to select this one and not the one that says just 3D. The URP here stands for the Universal Render Pipeline, which means our game will be playable on literally any platform. So we can make the final game and put it on Steam or consoles or mobile. It will run on everything. Then over here on the right side, let's quickly just download the template. There it is, it's done. Now select the name for your project. So I'm going to call this Kitchen Chaos and then select the folder for it. Alright, so that's it. Again, make sure you're using the exact right version. Make sure you're using the 3D URP template. Give it a name, a folder, and let's hit on create. Alright, so it's open, and right away you might or might not see a window talking about URP material upgrades. I think this has to do with the template not having the default materials updated to the latest URP version. So if you're watching this in the future, chances are you might not see this one at all. But if you do, then just go ahead, click on OK, and it will automatically upgrade all of the default materials. Alright, so here we have our basic Unity window. Now, since we started a project starting from the URP template, we have down here a bunch of URP helper files. So you can click to select the README file, and you can see it over here on the right side on the inspector. If you want, you can browse around these links in order to learn more about URP, but in our case, for building our game, we really don't need this. So over here on the inspector, let's just click this button to clean up these README files. Just go ahead, click on yes, and okay, that's it. So basically you should only have these files in your project window. So there's the scene folder, and inside we've got the sample scene, then we've got the settings, and inside a bunch of URP assets. All this should have been set up automatically since we use the 3D template. And then finally we just have the URP global settings asset. Now let's just verify everything worked correctly. So let's go to the top left, go into edit, then go down into project settings. Then over here, let's go into the graphics tab, and you should see the URP high fidelity asset assigned by default. If not, you can click on the circle icon and assign it. Then the other menus over here, the URP global settings. Again, this one should be set by default. Then down here on the quality tab, on this one, make sure high fidelity is selected. Basically, whatever you select here is the quality that we'll be using in the editor. And in turn, the selected quality over here also has a render pipeline asset. Now, in order to avoid any confusion, let's actually get rid of the other ones. So let's just click on the trash icon to get rid of the performance and the balance quality. So just click and click. Okay, so we only have this one. Then let's close the project settings and let's go into the settings folder. And over here, let's select the URP balance. There are 2 assets for each quality, so select those, leave the high fidelity and the performance, and let's delete these. Alright, that's it. By the way, if you made a mistake and accidentally deleted something, don't worry. You can always just click over here on the plus icon on the project window, and then go over here under rendering, and you can create a new URP asset with Universal Render. Okay, so just like this. So we only have one quality setting, we have high fidelity. The quality setting is using this render pipeline asset, which is also using this renderer. So that's really it. With this, we have the absolute bare minimum we need. If in the end, after building the whole game, you want to provide multiple quality settings, then you can come back to this menu and recreate them. But in order to avoid confusion while building the game, let's keep things like this as simple as possible. Okay, so that's the basic setup done. Next, we want to prepare our layout, so let's continue on to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the Unity layout and set it up. So first things first, let's familiarize ourselves with the various Unity windows to create our own layout. It's very important that you feel comfortable with your layout, that you have easy access to all the things that you need and you know where everything is. You can see that there's lots of tabs everywhere over here on the Unity window. All of them can be dragged and dropped in any different position. So you can customize your layout to get it looking exactly as you want. You can set it up in any way, but it will be easier to follow this course if you're following the same layout as me. I'm assuming you've seen my quick basics video, so I'm assuming you know what is the inspector, what is a game object, what is a transform, what is the console, what is the hierarchy, and so on. If this is the very first time you're seeing the Unity interface, go watch that other quick video first just to learn the absolute basics. Now for me, I've been using Unity for over 10 years now, so let's see the layout that I've developed over the years. First, the inspector on the right side, just like default. That way we always have a nice view of the selected object and whatever scripts and components it has. Then for the hierarchy, I like to put it down here on the left side. We're going to make sure that our scene is always organized, so we don't need the hierarchy to take up tons of space. Then with the project files next to it, this corner is enough to really browse all of the files. We want the console to be on the tab right next to it. Usually I find that when making the game, I want to look at the project window, but when playing the game, I just want to look at the console. So keeping them in the same place but on different tabs works great. Then over here on the center, the scene view, and again with the game view right next to it. Okay, so this is the basic layout that I normally use. Now for a couple more options, let's go into the project window. And on the top right corner, you can see over here these little 3 dots. By default, it shows you a 2-column layout, so there's a column here and a column here. But personally, I prefer the 1-column layout. This showcases all of the project files in a nice compact list view. The one thing where I prefer the other one is if you're browsing for some visual assets over here, you can increase the thumbnail size. But for most times, I really like to use the 1-column layout, much more compact. Also, since we're talking about the project window, just in case you don't know, there's over here this little button with the eye. This one has to do with package visibility. If you toggle it, then some of the installed packages are hidden, whereas if you untoggle it, then you can see all of the various packages with all the source code and so on. You can expand over here the packages, and right now it is showing all of them with source code, the things, everything there. And if you click on this, then it hides and only shows a bunch of core ones. But for the most part, you really want to leave this ticked and leave this one collapsed, nice and clean. Okay, so then on the console, over here, once again, let's go into the 3 dots. And for the log entry, for this one, I like to select 1 line. This makes the console nice and compact, which I personally prefer. You can see more logs without taking up more space. And if you want to read the whole log, you can always just click on it to see the whole stack trace. Now, there are also some more options over here if you want. For example, show the timestamp. This will show the timestamp when each message was sent. You can use a monospace font, meaning a font where every character has the exact same width. So a bunch of options, but for me, leaving it just like this works perfectly fine. Then also importantly, over here, these 3 buttons. These toggle the visibility for the type of messages that appear in the console. The left one, this one is for regular messages. We're going to use this a lot. Then we've got warnings and finally errors. If you untoggle them, then the messages of that type will not show up on the console. So if you ever come across an issue where nothing is showing up on the console, make sure all 3 of these buttons are ticked. Then on the left side, on clear, you can click on the arrow to see more options. I like to set it to clear on play. Then collapse. This one basically collapses messages that are the same, all of them into one entry. Personally, I do not like this. I want to see every single message as it comes out, even if it's repeated. I've also seen this lead to a lot of confusion for some people. They think their code is firing just one message when it's actually firing hundreds. So to avoid any confusion, make sure you leave this untoggled. Then for error pause, this will automatically pause the game when an error occurs. You should definitely have this one toggled. If there's an error, you definitely want to know about it. You want to know when it happens so you can fix it. Whereas if you untoggle this, you might get some errors and the game might keep playing, which will then lead to lots of confusion when something starts behaving weirdly. So always leave this one toggled. And then the editor button, this one is for a more advanced use case, so don't worry about it. Okay, so that's the console. Then over here for the game view, we've got a button here to select the aspect ratio. Let's go ahead and select Full HD. This one is a 16:9 aspect ratio, so everything is pretty normal. This will really only matter when we start working on the UI, but still I like to keep it as 16:9 always. Then on this button that says Play Focus, we can modify some options. Basically, Focus will play exactly like this on this small window. If you choose Maximize, then it will maximize this window when playing the game, and Play in Focus will play the game even when the window is not in focus. Then another important one is actually on the same one as the aspect ratio. Here we've got a button to toggle VSync. Usually when developing the game, you really want to toggle this. That's because right in the beginning, when the game doesn't really have anything, if you leave it untoggled, then this might run at like 1000 frames per second, and that will pretty much drive your GPU crazy. Finally, if your game view is looking a bit too pixelated, make sure over here on the scale slider, make sure this one is not zoomed in. This one should always be pushed straight to the left as much as possible. Okay, so that's the game view. Then over here on the scene view, for this one default should be good. These two buttons are extremely important. Pretty much all the time you want to keep the tool handles on the pivot and not on the center. If you ever see your handles on weird places, always come back to this. You want this on pivot pretty much all the time. Then for rotation, sometimes local is useful, but for the most part you should probably be keeping it in global. Then for the grid, showing the grid and Y, yep, that looks pretty good. A nice little visual grid. Then you've got a bunch more options if you want. Then next to it we've got snapping. This one we also don't need this for now. And finally, same thing for increment, also don't need this. Okay, then on the right for the draw mode, let's leave it unshaded. For 2D, let's leave this disabled since we're working on a 3D game. For lights, let's make sure this one is enabled. For sound, we're only going to add this in the end, so it doesn't really matter for now. Then for special effects, usually you want this one to be enabled so it shows everything. You can click on the arrow and make sure all of them are toggled. The only exception is always refresh. You probably don't need this little scene window to be refreshing at 60 frames per second, so you can leave that one unticked and tick all the others. Then these are for the hidden objects, so let's leave them toggled. For the camera, here are the defaults. And finally, gizmos, leave them all enabled as the defaults. Alright, so with all that said, here is the layout that I'm going to be using throughout the course. It will be easier to follow the course if you're using the exact same layout as me, so ideally you should be using this. But again, like I mentioned, all the windows are customizable, so if there's something that you absolutely prefer differently, then go ahead. You can drag and drop and place any windows anywhere you want. So once you have a layout you're happy with, you can go up here to the top right corner where it says default, you can click on it, and here you've got a bunch of layouts, so you can save your new layout. So I'm going to save this one as Kitchen Chaos, and then over here you can select any one you want. For example, if you ever have some issues with any kind of weird editor windows, you can load back the default layout and then go back and load your own layout. Okay, so with that, our layout is set up. The next important thing is setting up Visual Studio, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up our Visual Studio. Alright, so with the Unity layout set up, let's make sure Visual Studio is also set up correctly. I'm going to be using version 22 Community. This one is the free version. You don't absolutely have to use the same code ID that I'm using. You can use Rider or VS Code or whatever you want. So let's see my setup for Visual Studio. But first, let's actually set up something over here in Unity. So let's go up top into Window, and then let's open up the Package Manager. Then over here on the drop-down menu, let's select the packages and select the ones from the Unity registry. Then let's scroll down to find the Visual Studio Editor package. So here it is, this one. This package basically handles the integration with Visual Studio, so you can use the debugger and a bunch of things. Alternatively, there's also a package over here for Visual Studio Code, and there's also one over here for JetBrains Rider. So if you're using a different IDE, go ahead and install the package. For me, I'm going to install the Visual Studio one, so this one. Just go ahead and install. Okay, it's done. So next, let's go up into Edit and let's open up the Preferences. Then over here, let's go down into External Tools. And on the External Script Editor, make sure you select the one you're using. So again, for me, I'm using Visual Studio 22. And also over here, you've got a bunch of extra options. Now, if you want to play around with reading the source code for the various Unity packages, then you can tick all these boxes. But in our case, for this simple game, we don't need that. So go ahead and leave everything just like this with defaults. Okay, so with this set up, now we can go over here into Assets and open up the C# project. And this should open up Visual Studio. And alright, so here it is. Now for some more settings inside of here. In my Visual Studio, I have a really nice extension that adds a bit more colors to my code, which makes it easier to read and write. So up top, let's go into the Extensions menu and Manage Extensions. And the important one that I've installed is this one, VS4. If you want, you can go into the Online tab and over here search for it. And yep, it does show up in here. Then for the settings on that extension, let's go up here into Tools and let's open up the Options. Then over here, let's scroll down and find VS4. Yep, this one. And here are all the settings, and expand this and a bunch more settings. Now for me, I think these are only defaults. I don't remember if I changed anything. The important one is over here, the rainbow braces. So these have a bunch of colors which make it a bit easier to read the code. So let's create a simple script just to see this. So back in Unity, let's go into the project window, let's click the plus icon, and let's create a brand new C# script. Let's call it just testing, wait for it to compile, And now let's open. Now over here, I'm just going to write a bunch of simple code just to test it out. You don't have to follow this. Alright, so here's a bunch of sample code. These are the colors. You can see it makes everything a bit easier to read. Although again, this is not a requirement. You don't absolutely need this extension, but personally I do find it quite useful. I find that it helps make the code more readable than having everything be gray. Okay, so that's the setup for this extension. Next, for the text formatting options. So once again, let's go into Tools, go into Options, and then over here, let's go into the text editor. Then over here, I think I've got pretty much all the same defaults. Then we can go into the C# rules. So here are all the settings. If you notice something different on your end, go ahead and pause the video and compare the settings. But again, I think everything here is pretty much defaults. I believe the only difference that I did was over here on the code style. Over here for the new lines. Personally, I like to have the curly brackets on the same line, but if you want, you can also change it and put it on the second line. I think that's pretty much the only difference that I did. Everything else should be exactly the same as defaults. So that's the code style settings. And speaking of that, the next lecture is very important. We're going to talk a bit about naming rules. Although, just before we go, let's just clean up our testing script. So let's close this one, click on the X, then back into Unity. We don't need the script, so let's just delete it. Okay, so with that, we have Visual Studio set up and ready to go. Now let's continue in the next lecture to learn about some naming rules. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn something extremely important. Let's learn about naming rules. This one is a very important lecture that you should definitely refer back to whenever you have some questions. So first, what exactly are naming rules? These are really just rules you follow when writing your code. It is extremely important that you are consistent in applying your own rules. You don't want one class in your game to be written a certain way and then a different class using a completely different style. That would create tons of confusion. So naming rules and writing the code correctly is very, very important. One mistake that I see a lot of beginners do is they send me some code and ask why it's not working. Then I take a quick look and I see that all of the code is written in a very messy way. Some functions are in lowercase, others using snake case, some fields are in Pascal case, some in camel case, and so on. Remember that code is case sensitive, so it is extremely important that you write the code correctly. If you change a character from lowercase to uppercase, then you are suddenly referring to something completely different. If you're a beginner, keep that always in your mind. Code is case sensitive, so don't just write code semi-randomly. Write it properly as if you were doing an English literature test. Now with that said, when it comes to naming rules, you can use whatever naming rules you want. Different people like different rules. For example, you can use a prefix in your variables, you can use a postfix, you can use capitals for constants, camel case for properties, snake case for fields. By the way, here are the definitions of what those terms actually mean. Pascal case starts with a capital and every word is capitalized. Camel case starts lowercase and then uppercase for the first letter of every other word, kind of like a camel hump in the middle. And snake case is where you add an underscore in between the words. Like I said, every rule can be valid. The important thing is that you are consistent in always following through with your rules. As you might know, Unity mono behaviors have some default functions you can implement, things like start and update, which are written using Pascal case. Since you can't really change Unity's rules, at least on function names, I would say you should base your rules off of theirs. So for functions, you should probably be using Pascal case. For the other rules, like I said, choose whatever makes sense to you. Here are some of my own personal rules that I've developed over the last 10 years and the code style that I will be following in this course. For functions, I use Pascal case, just like Unity and just like the C# standard. For function parameters, I use camel case. For fields, also camel case. Properties are in Pascal case. Constants are in uppercase snake case. Then another rule is that I like to add the type of the variable as a postfix. So if it's a list, I append the list. If it's an array, I append the array. And now you might be thinking, with this, wouldn't it be an issue if you change the type, then the name is suddenly wrong? And the simple solution for that is that if I change the type, then I just use Visual Studio to quickly change the name. That's it. Then for the curly brackets, like I mentioned in the previous lecture, I like them on the same line. Some people have some very strong opinions about this. Really, it's just a visual style, and this is the one that I personally prefer. If you like Newline, then go ahead and use that. It doesn't change how the code works in any way. And a final rule, spend some time deciding on a proper name and don't be afraid to rename things. You will note how all the code that we're going to write in this course has proper names for everything. You should never use a variable with a single letter like X or K. The exception, of course, would be iterators in a for loop. Also, don't use acronyms or abbreviations. Those might seem clear right now, but in a few weeks you might not remember what they mean. Remember, you don't get bonus points for writing extremely compact code, so prioritize making your code readable and understandable, even if it requires variables and functions with long names. So these are my general rules and the code style that I personally follow. Figure out what works for you and follow your own naming rules. But naturally, in this course I won't be using my own code style, so if when following the course you're not sure how to write some type of code, you can refer back to this lecture and watch it again. Like I've mentioned many times, the code that I will teach you how to write in this course is on the exact same level of quality as my paid courses and my Steam games. So as such, because of that, this lecture, these naming rules are all extremely important. Okay, so with this very important lecture out of the way, now let's start playing with some visuals by importing some assets in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to import the project files with all the assets that we're going to use. By the way, remember that if you have any questions, go ahead and post them in the comments. I go through those every day and I'll do my best to help. Okay, so with the project created, the next thing we want is to import the assets that we're going to use to make this game. You can download all of the assets with a link in the description, which by the way, like I mentioned a while ago, that link contains a Unity package that contains both the assets and the final game. So when you download that, you get a Unity package. Just go ahead and double click or click and drag and drop it on the projects window. Here is the asset import window, just make sure you select all and let's import. Okay, so here it is. This imported the assets folder and inside comes all of the assets, meshes, textures, and so on. So everything we're going to need. And then it also imported inside of it another Unity package. So if you want to import the final project with all of the code already written, it's also here. If you extract this one, you're going to get the complete project files. Now, of course, don't do that if you want to follow along with the course. And be aware that if you're following along and you accidentally unpack this one, it will overwrite all of your own files. So if you want to inspect the final project files, go ahead and do that, but do that in a separate project. In order to make sure that we have no accidents, I'm going to delete this one from the current project. So just go ahead and delete. Okay, so that's it. And over here we've got all of our really nice visuals. We can look in the prefabs visuals, and over here we've got a visual for a container. So there we go, that's a container counter. Then we have a cutting counter. We've got a trash bin. Then on the kitchen object visuals, we've got all the visuals, so a block of cheese, we've got some burned meat, we've got a plate, and so on. These are all the nice 3D models that we're going to use in our game. And then over here on the textures folder, we also got a bunch of general icons, as well as actual icons for all of the various parts. Okay, so all of the assets have been imported. Now let's continue on to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up post-processing. Now here, let me make a quick note. Usually when making your games, you probably don't want to handle post-processing right away. You should first get an ugly prototype up and working before you worrying about any visuals. So normally I would only add post-processing much later on in the dev process, but since this is a course in video format, in order for the video to look a bit more appealing, let's set up post-processing right away. Now we already have the project set up to use URP, so adding post-processing is actually super simple. It's actually already added by default. First, before we do that, let's rename our scene with a proper name. So inside the scenes folder, it starts off with sample scene. This will be our main game scene, so let's just rename this to game scene. Okay, and now here on the hierarchy, we can see by default, this scene already contains a global volume game object. This is how you actually add post-processing. And by default, you can see that it also already has a sample profile attached. This is how you add all of the various effects. You can click on this link and it will show it over here on the project window. Now let's build this from scratch instead of starting from this one. So let's go into that file, into that asset, and just delete it. Okay, so now we have no volume profile. Now let's go ahead and click on new to create a brand new one. Okay, so now here we can add overrides, add all of the effects that we want. Let's drag some visual meshes that we imported in the last lecture to get a better look at all of these effects and what they do. So first let's make some kind of floor. So let's make a 3D object. Let's make it a plane. Let's name this the floor. Also, one extremely important thing, whenever you create a brand new object, always check the object's transform position. By default, when you create an object, it appears in front of the scene camera, which will probably not be on 000. You always want to be very careful with the position of your actual objects. So for a plane, we do want this to be on the origin, so on 000. So make sure you always do that. Then let's scale it up a bit. So on the scale, let's put it on 555. Which, by the way, you've got this nice little icon. This was added in a recent Unity version. Basically, if you enable this, then it matches all of these values. So if you just change one of them, it changes all of them. So let's put this on 5. Okay, great. Now for the visual, let's go ahead into the mesh render on the materials, and let's select a brand new material. So let's click on the circle icon. And over here, let's find the floor material. So here it is. It's the one included in the assets. So there we go, we've got a nice basic floor material. Now let's also drag the player visual, so let's go inside the assets folder, and over here let's go inside the prefabs visuals, and down here we find the player visual, so let's just go ahead and drag this one. So there it is, a nice player visual. Let's also drag a counter, so let's find, let's say the clear counter. Let's drag this one. Let's rotate it to face the camera, something like this. And let's also put a cutting counter. Again, we're just placing some visuals just so we can see what the post-processing will do. And let's also place a bunch more things. So let's say a tomato. Let's place a tomato over there. And maybe a cabbage all the way over here. Okay, so we've got a handful of nice visual elements so we can test out our post-processing. By the way, here's a quick Unity tip on scene controls. Whenever you are on the scene view, which make sure you're on scene view and not game view, those are different. So on the scene view, you can move the camera with the mouse. You can pan with mouse 3, so the middle mouse button. So hold that and pan it around. You can rotate with the right mouse button. You can rotate around the point by holding down left alt and left click and just drag it around. To rotate around an object, you can select an object, like for example player visual. Then you can press on F to select that object. And now if you hold alt and click, it will rotate around that object. Also another method is you can hold the right mouse button to move it around, and then you can use WAS to move, so D, A, and so on. Then you can even press Shift to move in faster. And you can use the scroll wheel whilst holding down the right mouse button in order to modify the speed at which you move. So there are plenty of camera controls to really get you seeing exactly what you want to see. Now for another quick Unity tip, you can move the scene camera to where you want the game camera to be. So let's say I want the game camera to see things from about this angle. So you just position the scene camera. Then on the hierarchy, select the camera game object, so the main camera right here. And with that object selected, you press Ctrl, Shift, and F. And if there you go, you can see over here on the camera preview that it positioned the main camera looking on the exact same position at the exact same direction as the scene camera. So that's the shortcut Ctrl, Shift, F, or alternatively go up into game object and over here align with view. Now if you look, here is the scene view, and over here we've got the nice camera view. So just position the camera somewhere where we can view all of the assets. Now with this, let's add some post-processing effects. So first, let's select the global volume game object, and over here we can add all of our effect overrides. First up, let's begin by adding tone mapping. So there you go, we've got the effect, and over here we've got a nice little checkbox, so you can enable it in order to enable this effect and set one of the options. Now for this one, I'm not too familiar with color correction, but I find that usually adding a neutral tone map, usually that helps. Also make sure you're looking at the game view and not the scene view. If you're looking at the game view and you enable and disable this effect, you should see a difference. Whereas on the scene view, if you enable and disable, it doesn't actually show that. Even if on the scene view over here you have all the effects enabled, even with that, some effects for some reason don't show up on the scene view. So when playing around these effects, always make sure you're looking through the game view. So like I said, you should be able to toggle this and see a visual difference on the game view. If you don't, then make sure the camera has post-processing enabled. So let's select the main camera game object, and down here there's a toggle for post-processing. Make sure this one is enabled. And then also on the render pipeline assets, so let's find that one on the project window. Over here we've got the settings, and you've got the URP high fidelity. This one should be using a renderer, so if you click on the renderer, over here you should have post-processing enabled. Again, all of this should already be correctly set up by default. So if you go into global volume and enable or disable, you should see a visual difference. Okay, so next effect. One that I always like to add is a bit of saturation. So let's add an override, post-processing, and let's add a brand new, here it is, color adjustments. Then over here, you've got plenty of things to play around with. For me, I like to add a bit of saturation, so just lift it up a little bit. Let's say just about 20. And I also like to add a little bit of contrast. So over here, let's also add 20. And there you go, it makes the colors pop a little bit more. So personally, I like this effect. Then later on, we're going to have some glowing objects, for example, the stove. Let's actually try dragging that into the scene. So let's go into scene view, and in the assets, let's find the stove counter. So here it is. And inside the stove counter, there are some things. So here it is, the stove on visual. This one is disabled by default. So on the inspector, let's just enable this game object to make it visible. Again, don't worry about the positioning of the objects on the scene view right now. We're only positioning them just to set up the post-processing. We're going to delete them all at the end of this lecture. Okay, so that one enabled. Let's go into the game view, and over here we see the stove enabled. So now let's go into the global volume. Let's add an override, go into post-processing, let's add a bloom effect. So right now, notice how that one is not glowing red hot. For that to work, we need to have bloom, and we need to enable the threshold and the intensity. If we raise the intensity, we do see, yep, there we go, a really nice glow there. By the way, here's a quick visual tip. If you want to make your game feel a bit more ethereal and magical, one good way is to put the threshold at a low value, below 1, so something like 0.5, and then put the intensity as a little bit. And with this, notice how everything has a slight glow, even colors that don't have any extra intensity. So the floor is glowing, the character is glowing, so everything looks quite a bit ethereal. This is a bit extreme, but it is an interesting effect. Also, another quick note here, in case you're not seeing anything change, make sure you go into the render pipeline assets, so the URP high fidelity, and over here make sure AGR is enabled. You can look at the stove glow. If I disable it, yep, that one stops glowing, and with that enabled, it does start glowing. AGR stands for high dynamic range, so that is how you can have a color go with an intensity above 1, which actually makes it glow when you have the bloom post-processing. If even with that you're still seeing issues, then make sure you go into the renderer, and over here for the post-processing, sometimes Unity has a weird bug and doesn't generate this post-process data file. So if that does happen, just go ahead, untoggle and toggle this, and it should work. And finally, like I said, on the camera, make sure you have post-processing enabled. So with all of that, you should be able to see the game view glow. Okay, back into our effects. With our bloom working, like I said, you can lower this below 1 to get a nice ethereal look, but this is a bit too intense on what we want, so let's make it a bit more subtle. So on the threshold, let's put it at 0.95. So there's a slight glow on the white parts, but nothing too intense. And for the intensity, let's put it at a regular 1. Okay, so I think that's a nice amount of bloom. All the colors glow a little bit, and we can see over there the stove, it is indeed glowing. Okay, great. Now, if you ever forget all of these steps and you can't get your project to glow, I made a nice video with a nice checklist of everything needed for you to glow. Definitely go ahead and watch that video whenever you have issues. Then for another fun effect, we have vignette. So let's go into add override, post-processing, and let's find the vignette. What this one does is adds a bit of darkness to the colors. So if we enable the intensity and we increase it, you can see what it does. So it adds darkness right on the corners there. Personally, I find this one looks good when it's quite a bit subtle. So let's put the intensity at something like 0.25. And then for the smoothness, let's also put it on 0.4. So just like that, just a slight darkness on the edges. So personally, I think it looks pretty good. And that's pretty much it for the post-processing on the volume component. I like how this looks. You can see the difference with the volume enabled or disabled. Quite a big difference. Looks pretty nice. But again, these are just visuals, so feel free to play around, maybe add some more effects, use some different settings. These are just visuals. They don't impact the game logic at all, so feel free to make it work exactly as you want it. Then yet another thing related to post-processing but not in this component is some anti-aliasing. For that, one place where you can change it is on the main camera. Over here you see a field for post-processing and you have a bunch of types. So FXAA or SMAA. Or if you want some more higher end post-processing, you can go into the render pipeline assets, so URP high fidelity, and over here we see anti-aliasing MSAA. This one is a bit more expensive, but looks a bit better. If you want to see the difference, you can go over here into the game view, and on the slider up top on the scale, you can increase this quite a bit. So with this, we can now see the pixelation, and you can see over here if I switch anti-aliasing from 4x back into disable, you can see lots of jagged edges. And if I put it on 2x, yep, looks a bit more smooth, 4x a bit more smooth, and 8x even more smooth. So with that, you can see the difference on all the edges, all the things. By default, this renderer has on 4x and nothing on the camera. This already looks pretty good, but to make the video look even better, I'm going to put it on 8x. And on the main camera, I'm also going to leave it with no anti-aliasing. You can combine them, but if you do, then everything looks a bit too blurry, so I don't quite like that effect. So put this one on none and the other one on 8x. Although, again, this is just a visual, so if you have a low-end PC, feel free to go into the URP, and over here, disable anti-aliasing. So the game looks a bit worse, but it will run much better. Okay, let's drag the scale back down, okay. Now, one final thing we can add is some really nice screen space ambient occlusion. For that, let's go into the renderer, so not the render pipeline asset, the renderer. And over here, by default, it already added screen space ambient occlusion. If it didn't add, you can click on add renderer feature, and over here, you won't be able to see it. I don't see it because I already have it. Okay, so here it is. Basically, what this effect does is it adds some tiny shadows where geometry intersects. If we enable and disable it quickly, we can see the effect over there on the counters. So you can see with the default effects, it already works quite nicely. For example, look there on the player. We can barely see the difference between the head and the body, but if we enable this, it adds that nice little shadow. I think it looks really nice. But then we've got a bunch of settings we can play around, increase the intensity, the radius, and so on. Now, one important thing when setting all of these effects is to remember the point of view of the camera. In this case, we're making a top-down game. So before we play around with these settings, let's actually position the camera in a correct position. So let's go ahead, select the main camera, and let's position it above pointing down. So let's put it on an X of 0, on a Y of 21.5, on a Z of minus 21.3, then for the rotation on the X 46, then 0 and 0. And finally on the camera over here on the field of view, instead of 60, that's really wide. For this game, let's go with 20. Okay, so this is the view that we're going to use for our game. Let me just rotate the objects so they actually face the camera. So on the hierarchy, let's just select all the objects. Let's rotate them all around and just position them. Again, we're only using these just to see what they'll look like. We're going to delete all of these objects in a bit. Okay, so yep, that's the game view. Now that we have the camera set up, let's work on the settings for the ambient occlusion. So let's go down, select the renderer, and over here for the settings. For the intensity, let's put it on 4. For the radius, let's put it at 0.3. And direct lighting strength, let's put it all the way up to 1. Okay, so you can toggle this, enable and disable to see the difference, and yep, I do think these settings look pretty good. Finally, the last thing we need to check is the lighting window. So let's go into window, then down into rendering, and let's go into lighting. Out pops up the lighting window. Personally, I like to anchor it over there next to the inspector. And over here, we're really going to leave everything on defaults. So you can leave it as the lighting settings assets and nothing assigned. And then on the environment tab, over here, again, all of the defaults, I didn't touch any of these. So we've got environment lighting from the skybox, intensity multiplier of 1. So everything pretty much on defaults. Although again, like I said, most of these visual effects are very much personal preference. So if you want to make your game look a bit different than mine, then go ahead. You can play around with lighting over here. You can change skybox to gradient color and so on. If you want, you can use some baked lighting. Then if you want, you can add all kinds of extra effects. And also, by the way, remember that the effects are stored on this profile over here. So for example, you can click over here on the clone button and it will clone the effect. So let's click on it to find it. Yep, there you go. So that's the one that I built and here's a clone one. So if you want, you can make a clone one and then make it look very different. For example, let's go into chromatic aberration, make it really intense. And for example, let's go into the color curves. And over here, for some reason, let's drag the green up and so on. So there you go, completely different visual. So if you want, play around, make some weird effects. And if you want to go back, just revert back into the original profile. Personally, I'm quite happy with how this looks, so I'm going to be using this one, okay? Again, you can enable and disable the volume game object to see quite the big difference that post-processing makes. If you ever want to make your game look quite a lot better, always make sure to add some post-processing. Alright, so like I said, this looks really good. I like it. Now, before we go to the next lecture, let's just clean this up. So let's get rid of all of these objects. So the counter, cabbage, tomato, and so on. Let's get rid of all of them except the floor. So let's leave the floor and get rid of all of these. Alright, so here we have our nice empty scene. Let's just save our scene and let's get ready for the next lecture. Hi there, this is a quick intermission. So how are you doing? Are you enjoying the course so far? Are you having any trouble with anything? Is there something you didn't understand? If so, remember I'm always active in the comments answering all the questions. So if there's anything you need some extra clarification, go ahead and ask and I'll do my best to help. Also remember to check out the pinned comment. YouTube videos cannot be updated, so for any notes or comments, I'll put them in the pinned comment. And definitely check out the website page for this course. As people ask more and more questions, I will keep that page updated with any frequently asked questions for every single lecture, so that way you can see what others have asked and learn from them. And you can also download the project files for each lecture, so keep that page open on a second tab and check it every time you start watching a new lecture. I really hope you're enjoying the course, and I hope you've already learned quite a few things. Go ahead and hit the like button and subscribe to the channel if you haven't already. Okay, so let's go to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to begin creating our character. Let's make a nice character controller so we can move our character in the world. Okay, so first let's begin by creating the character game object. And now, usually, most beginner tutorials would tell you to just right-click, go into 3D object and create something like a capsule. That way you would have the game object with the visual included. However, for a good project structure and good organization, you should always separate the visuals from the logic. For example, here, let's say that I don't want my capsule exactly like this. Let's say that I want my player to be a little bit more skinny. To do that, I would have to modify the scale on this game object. So put it maybe on 0.7, so something like this. Basically, by doing that, by modifying the visual, I also modified the scale on the actual player game object. Having a non-uniform scale on a logic game object, that can cause all kind of problems with any kind of logic component. Also, I would prefer to have my character on the floor, but if I put it on y of 0, notice how the character is half underneath the floor. So if I were to use this method, I would have to apply some kind of offset in order to make the visual above the floor. So that would require rearranging all the logic to work with an offset on the y position. So because of those reasons and many more, you should not place both the logic and the visual on the same game object. Instead, you should separate them. So let's get rid of this, and instead, let's create an empty game object. Let's name this the player. Let's put it on 0, 0, 0, okay? And now inside of it, let's create, let's say, a capsule. Now in this one, we can easily scale this to get any size and shape you want. So for example, 0.7, 0.7. Then since the visual is a child of the game object, we can also easily offset this. So let's say put it up by about 1 unit. So with this, we can position the visual so that basically the player game object is over here on 0, 0 and the character is above the floor. So we don't have any weird offsets. This will make all of our logic much more simplified. And now on this empty parent game object, we can attach all of the logic components we want. And then in the child visual, we can add or replace whatever visuals we want. So as a general rule, you should always try to do this. Always separate the logic from the visuals in your game object. Okay, so with that we have the player game object. Now let's make our character controller script. And before we do, let's keep things once again organized. So before we do, let's create a brand new folder. So let's right click on the assets, create a brand new folder, call it scripts. And now inside, let's right click and create a new C# script, call it the player. Wait for the code to compile, then select the player game object and attach the script. Again, remember logic components go on the parent game object, not the child visual. So the child visual, this one only has visual components, and the player, this is the one that actually has the logic components. So let's open up this script. Okay, so here's our first C# script. Like I said, I'm going to assume you know the absolute basics. Go watch the C# basics video if you haven't seen it yet. So I will assume that you know what is a function, what is a variable, what is start and update, so pretty much the absolute basics. For a character controller, we first need some input from the player. And for that, Unity actually has two methods. You have the Legacy Input Manager and the New Input System. Basically, the Legacy Input Manager is super simple and very easy to use, so this one is perfect for quickly prototyping. And the New Input System is extremely capable with tons of features, but it's also a bit more complex. So what I do is while I'm doing a simple demo or testing out a new prototype, I just use the Legacy Input Manager, but when making a more complex project, like for example my Steam game, then at a certain point I refactor my code to use the New Input System. So here I'm going to teach you both, as well as teaching you how to refactor code, which is an extremely useful skill. So let's first begin by using the simple Legacy Input Manager. We want some basic WASD movement to move our character, and we're going to need to run that logic on every single frame, so let's do it on update. And let's actually get rid of the code that Unity writes by default. Let's start completely from scratch, so let's get rid of this, just close, okay. So here, let's start by writing private void update. And now here, very important, if you're a beginner, make sure that update is written exactly like this. If you write update with lowercase, if you do this, then it won't work. The function will not be called automatically. I'm pointing this out because I have seen a bunch of comments from beginners wondering why their code doesn't work, and it's as simple as this. With lowercase, Unity will not call this automatically. It needs to be exactly perfect. So again, if you're a beginner, make sure you write the code exactly. The code is case sensitive, so this is very important. Also, another note, you saw that the code that Unity wrote by default when we made a new script, it just had void update. It did not have the private keyword. Private is what is called an accessor. You have private, then you have public, and then there are some more advanced ones. Technically, you can omit the accessor, and in most cases it will default to private. However, in writing good clean code, you should be as explicit as possible. There should be no room for misunderstandings. So while technically you could omit the private, you should always include it to make your code easy to read and easy to understand. This one is the first of many clean code rules that I will teach you during this course. Like I said, all of the code that I'm writing here is on the same level of quality that I use in my own professional games. I'm not going to teach you bad practices like so many beginner tutorials do. So always be explicit, always include the accessor. Okay, so we have our update running code on every single frame. Then to test if a key is being pressed, we just go inside input. Then over here we've got two functions. So we have getKey and getKeyDown. Both these functions return a boolean, so that's either true or false. The difference between them is that getKeyDown, this one only returns true for a single frame when the key is pressed, whereas getKey, this one stays true for as long as the key is held down. For example, for an action like jumping, you just want to know when the player presses the button. So for that one, you would use getKeyDown. However, in our case, for a character controller, we want to know if the key is being held down. We don't want just one frame, but always. So for movement, let's make sure we go with getKey. That requires a key, so let's write our key code and then choose the key. Let's say we want W. And then let's just put this inside an if, just like this. Okay, so here we have code we want to run while holding down the W key. Let's do a quick test just to verify everything is working perfectly. And for testing, we can use a super useful debug.log. This one lets us print a message in the console. So let's add one log here, just say something like pressing. And then let's also do an else, and if else, let's do a debug.log and just do a dash. Okay, so here is our very basic script. Let's make sure to save it, so Control S. Then back in Unity, over here, make sure you have the script attached to the player game object. And now we can test. And now down here on the console, we can already see dashes, so I'm not pressing any key. Also, like I mentioned in the setup lecture, if you're seeing just one message, then maybe that means you have over here the collapse toggled. If you toggle it, look how it only shows one message, but then over here on the right side, it says the number of messages. Personally, I prefer to always keep it untoggled so I can see every single message. Also, over here on the right, make sure you have info messages visible. If you untoggle this, then you don't see it, so make sure this one, and actually both of them, make sure all of them are enabled. Okay, so we're seeing a whole bunch of dashes. And one more note, if over here the scroll bar stops scrolling, so right now you can see it's stuck up instead of being down there. So if that happens, one easy way to reset that is just click over here on clear and it goes back into auto scrolling. Okay, so we have the dashes. I am not pressing any key. Now as I press, yep, there you go, there's the message. If you don't see it, make sure the game window is in focus. So select the game view and click right here on the middle to make this one the focused window. Then if you press the W key, you should see the message. And if I let go, yep, there it is, a nice dash. Okay, great, so all the basic logic is working. Back in the code here, now that the logic is working, let's get rid of the else here. And let's add tests for all of the other keys, so let's copy paste this. So we're going to need W, A, S, and D. So let's make all of these. Okay, so we have our inputs. Let's also get rid of the logs. We don't need this. All right, so we have all of our key presses. Now let's construct a vector with our inputs. And since we're just going to have two axes, the WS, that is forward and backwards, and this one is left and right, so just two axes. So because we have just two, let's use a vector2, and let's call it the input vector. Let's construct it, so we'll do a new one and start off at 0, 0, okay. Then over here, the logic is pretty simple. So when we press W, then let's go into the input vector and set the Y to +1. Then when we have an S, we want to go backwards, so put the Y on -1. For the A, we want to go left, so that's an X on the -1. And finally for the D, that is an X on +1. Okay, so with this, we have our correct input vector. Let's do a quick log just to test. So debug.log on the input vector. Okay, so let's test. All right, so we can see in the log 0, 0. Okay, makes sense. Now if I press W, yep, we've got a 1 on the Y. If I press A, we got -1 on the X. Press D, +1. Press S, and -1. Okay, great. So everything works. Except we also need to be careful about one other thing. If I press both W and D, with this, look at that, the vector is 1, 1, which is correct. That's exactly what we did. Except the vector 1, 1 actually has a bigger magnitude than just one vector. If we leave it like this, then the character will move faster when moving diagonally versus when moving in just one direction. For our input vector, we really want it to be normalized, meaning we want it to have the same size regardless of the combination of keys that we're pressing. So back in the code here, after calculating the input vector, let's simply normalize it. So we go into the input vector and we set it equals to input vector dot normalized. So this will normalize our input vector. Let's see. Now over here, if I press W, yep, got 1, press S, -1. Okay, so all of those work. Now if I press both W and D, yep, there you go. Now it says 0.71. When you combine both these and you do the math, these do end up with a magnitude of 1. So with this, our character will move at the same speed on both diagonals and straights. Okay, so we have the input vector all correct. Now let's actually apply some movement. For that, there are many ways of making a character controller. For example, you can decide to use physics or not. Over here, I want to keep the game simple, so let's not use physics. Instead, let's just move the player transform directly. Over here, we have our input vector. Okay, great. Now we want to apply this to our character position. So first, we access the transform. This one refers to the transform where this script is attached to. This script was attached to the player, so this is going to refer to the player transform. Then we want to modify the position, so let's access the position. And now for moving, we don't want to just assign it. If we do something like this, the player would never leave the center of the world. It would always be near 0, 0. So instead, we don't want to just assign it, but instead we want to add onto it. Now, if you're a complete beginner and you don't know this syntax, then this one is exactly the same as this. So transform.position equals transform.position plus input vector. So both these two lines are doing the exact same thing. Personally, I prefer to use the shorthand. I find that equally readable and more compact. Okay, so we have this, and we add our input vector to the transform position, except we can also see a really nice error. Basically, it's telling us that we are mixing two types. Our input is a vector2, where we only have an x and a y, but transform.position is a vector3, meaning it has an x, y, and z. One simple solution is to cast our input vector onto a vector3. So we just convert this from one type into the other one. And yep, we don't have the error, so let's test. And now if I press W, and yep, the character does move. Let's ignore the massive speed for now. So it does move, it does seem slightly correct. Except you can obviously notice that it's not correct. We are moving on the x-axis, so left and right, that is correct, but then we are moving up and down instead of forwards and back. Basically, we converted the vector2 directly into a vector3, so we are moving on the x and y axes. But in our 3D game, we really don't want the characters to fly, so instead we want to move on the xz axes. So back in code here, instead of directly casting this down into a vector3, let's construct a move dir vector. So let's do a vector3. Let's call it our move dir for our move direction. And over here, we construct a new vector3. And basically, we're just going to assign the input y to the z on here. So first of all, for the x, that one is correct. So input vector.x. Then for the y, let's leave this one on 0. And finally, let's use the input vector.y as a z on the move direction. Also, now at this point, you might be questioning, if we're using a vector3 here, why don't we also use a vector3 up here and then just assign the z directly? That's certainly a possibility, and for making a super quick prototype, I might even do that myself. But the proper answer to that is once again all about writing good clean code. The input logically only has two axes. There's no z-axis on your keyboard, so logically it makes no sense for the input to have three axes. And beyond that, you should keep the logic separate, so you should first get the input and then actually move the object. We're going to see the benefit of that separation when we refactor this code to work with the new input system. Doing that will in turn make enabling gamepad joystick support super easy because we have the input vector separated from the actual movement. So all of that to say, let's do things properly. Let's keep the input vector separate from the movement vector. So we just translate the xy onto xz, and then we just apply this into our transform position. Okay, so let's test. So now if I press D, go right, go left, and press W and S, and there you go. Okay, great. So it is indeed moving left, right, forward, and back. Okay, great. So it is working, but as you can see, it's moving insanely fast. You might think the issue here is just applying some sort of movement speed multiplier, except there's actually one sneaky issue here. Here on the game view, on the top right corner, we've got a stats button, and over here we can see a whole bunch of things. Specifically, we can look at the frame rate. We can see that it's running at 144 frames per second. Over here on the left side, on this button, I have VSync enabled. This will cap the frame rate to the monitor's refresh rate, so that is why I'm seeing 144 Hz. I can over here disable VSync, and yep, look at that, goes all the way up to 700. Basically now the game is running as fast as my computer can run it. And if I press the movement keys, and look at that, now it's moving even faster. Now I've completely lost track of where my player is. This is not what we want. We don't want the player to move at different speeds depending on the frame rate. We want it to always move at the same speed regardless of frame rate. So when you do any kind of movement logic on an update, you always need to make sure to multiply by time.delta-time. What this variable contains is the number of seconds elapsed since the last frame. For example, let's add log to this. We no longer need the input vector, so let's log just the time.delta-time. Okay, so we can see that is basically telling us how many seconds it is taking to render a single frame. Once again, note how I have VSync enabled, so I'm running at 144 frames per second. And now if I disable it, let's see what happens to that number. So if I disable, and yep, look at that, that number is now much smaller and the game is now running much faster. So by incorporating this value into our calculation, we are going to be taking into account the frame rate, thus making sure that the movement is always frame rate independent. Right now with this frame rate, if I move, you can see I'm moving at this speed, and now if I enable VSync, change the frame rate, and I move and I'm still moving at the exact same speed. Okay, that's great. Except obviously it's not exactly great, it's moving way too slow, so let's also incorporate a movement speed. Now for this, once again, most beginner tutorials would teach you to go all the way up here and define a public float move speed. Maybe default it to some value like 7f, something like that. Then you have this field, and then down here you simply use it in the calculation. So movement here, multiplied by move speed and by time.delta-time. So this is what most tutorials would teach you. By making it public up here, what you're doing is you're enabling access from the editor. So if you go over here in the editor, over there on the player, we can see the move speed variable. We can see this exposed and we can modify it. This makes it really easy for testing and for iterating upon the value even while the game is running. So the game is playing, I can move and I have this move speed. Now I can modify this, and yep, now I got a different move speed, so I can use this to quickly iterate and find the perfect value. So it's great to have this variable exposed in the editor. And this feature is indeed the reason why most beginner tutorials would teach you to make it public. It's so you can see it in the editor. That is indeed a very valuable thing. Being able to easily iterate upon important values is always very useful. However, when you make something public, when you do that, you don't just expose the field to the editor, you are exposing it to every other class in your entire codebase. So some other class could access this field and set the player's movement speed to something like 0, and you would have no idea that was happening because the issue would not be on this code right here. I have an entire video on this subject, why you should not make everything public. This is an extremely important topic to know about. This one tiny change will massively improve the quality of your code. Definitely go ahead and watch that video to learn why it's such a bad thing and make sure you don't do it. So to avoid all kinds of problems, you should never make fields public. So very quickly, the obvious alternative is make it private. Making it private means that only this class, only the code in here, only this can modify this field, so you know for certain that no other class can ever modify this. However, making it private also means the editor cannot modify this field. So we've lost our very useful iteration approach. So what we can do to expose it just to the editor is to keep it private, and then we add the attribute serialize field. This way this field is still private, meaning that it can only be modified by the code inside the player class. But with this attribute, over here in the editor, yep, we do have an editable field. So only the code in that class in the editor can modify it. Nothing else can touch it, nothing else can read or write, which is exactly what we want. One of the main rules in writing good clean code is minimizing complexity, and one of the easier ways to minimize complexity is simply to minimize access. By making this field private, we are minimizing complexity because it doesn't matter how complex our game is. Maybe our code base is 1,000 classes long, it doesn't really matter because only this class can ever touch this field. So if we have a bug related to movement speed, we know for certain it has to be inside this code and nothing else. So we minimize the things we need to keep in our head, which is always a very good thing. Okay, so with all that said, we have our movement speed, and down here we are incorporating it into our calculation. Just with this, we have our character working with a variable movement speed, and by using delta time, we have our movement correctly being frame rate independent. So here's our character, and using the keys I can walk around and yep, the character moves in any direction. So we have movement fully working while using the legacy input manager. Like I said, we're going to learn how to refactor our code to use the new input system. Learning how to refactor is an extremely important skill to improve your own programming skills. It is something that you should always do when necessary. It will massively help you improve the quality of your code. So we're going to do that, but before we get to that, let's actually do something a bit more fun and add some proper visuals and animations to our player in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to replace our boarding capsule visual with a nice proper character mesh. Okay, so in the included assets project files, over here, if we go inside the prefab visuals, we see a nice player visual. Let's position it inside the player game object, so let's drag it inside. Again, because we separate the logic and the visuals, this is going to be pretty easy. We don't need to modify the parent game object at all. We just drop the visual as a child, that's it. Also, again, very important, make sure the visual is over here on local position 000. Only the parent game object should move, the visual itself should never move. If you notice some weird positions as your player moves and rotates, always check to make sure that the child visual is on 000. Okay, so with this, let's delete the old capsule. Delete it, okay. So here we have a pretty simple but really nice character visual. It's really just two spheres stacked on top of one another with a bunch of eyes. Very simple. For the visual itself, the material is using just a solid color. So here it is inside the assets material. You can see a bunch of player bodies with different colors. These different colors, they won't be used in the upcoming multiplayer video. Basically, each player will have a different color. Also, by the way, if you're a complete beginner, here's a quick lecture on materials. These are materials, and if we click select, we can see a bunch of stats related to that material. Basically, the materials have a shader and then a bunch of properties. Now, the shader is the actual code that runs on the graphics card that says how an object should be rendered. By default, you have a whole bunch of included shaders. We're using the universal render pipeline, so you should mostly be using the ones inside the URP. And by default, you probably want to be using the standard lit shader. Then of course, you can also build your own custom shaders. One excellent tool for doing that is ShaderGraph, which I have covered in detail in a previous video. It's a fully visual tool that you can use to make shaders without having to write any shader code. It's a great tool. I've also made a bunch of tutorials on all kinds of effects you can make, although right now we're not going to be using custom shaders. We're going to do that later on in the course, but for now we're going to stick with the default lit shader. So materials have a combination of shaders and the properties on that shader. For example, over here for the default lit shader, you can see that it has over here a base map, that it has a color field. This is what you can change to apply a different color to your player. Also, as to how you apply a material to an object. Over here on the player visual, you can see the objects are made up of a sphere. So this is the mesh and then the mesh render. This is the one that has the material. So both these are what stores the shape as well as the visual for the object. The mesh is just a 3D shape, but just by itself, the mesh filter doesn't actually render anything. So it needs a mesh render, which needs a material attached to it. So for example, over here on the hierarchy, let's right click on empty space and let's create a brand new cube just to see it. So yep, there you go. It does create an object, and as you can see, it has a mesh filter and a mesh render. Now to apply a different material, you can click on this little circle icon and it shows you all of the materials in that project. Alternatively, you can grab the material directly from the project window. So for example, the player body, just grab it and drop it in there. Or you can also drop the material over here on scene view. As you can see, as I mouse over different objects, it applies that material to a different object. Although note, that only works over here on scene view, it does not work on game view. So this basically sets the material over there on the object. Now, one more very important thing on materials. If you have multiple meshes only using the exact same material, and then you modify the material, it will change the visual on all meshes using that material. So for example, if I modify the color here, put it on something different, there you go, all three instances, all three objects that are all using the exact same material, they all update with a new color. If for example, you wanted the head to be a different color from the rest, then you would just create a new material. So you can right click on the project window, let's create a new material, then you can give it a name, give it colors, use a different shade or whatever, and then use this one for something different. So that's pretty much the basics for materials. And by the way, if you're a complete beginner and you have questions, remember to post them in the comments and I'll do my best to help. Like I said, I want to keep this video moving. I'm trying to teach teach as much as possible while still keeping the video a reasonable length, so if you need any further clarification on anything specific, just go ahead and ask in the comments. Okay, so with the materials out of the way, here we have our player with visual. Let's just get rid of our cube, okay? And just with this, if we test, and yep, over here we already have a nice player visual walking around. Okay, great. Except the player isn't actually rotating. Ideally, the visual should be facing the walking direction, so if I walk down, it should be rotated to face down. So let's add that. Doing that is actually going to be pretty simple. Let's go into our script. Here we are on the player script, and over here we already have the movement direction. So we're going to use this in order to make sure to rotate the game object to face this move direction. And for rotating a transform, there are many ways to do it. One obvious one is to modify the transform.rotation. However, this one, as you can see, works with quaternions. For me, even though I've been doing game dev for over 10 years, I still find quaternions quite a bit confusing, so I normally don't use this method. Another method is to modify the transform.Euler angles. This one is much more intuitive and makes more sense to me. It works with regular Euler angles, which is much easier to understand. If you don't know that name, it really just means the angles that go from 0 to 360. Then for another method, you can also use the function transform.lookAt. This one makes the transform look at a certain point, so it can be a transform target, can be a vector 3 for one position, anything like that. So this is a very useful function. We could calculate a point right in front of our move direction and look at it. Or finally, the method that I personally like to use for this specific purpose, which is just modify the transform.forward. This one has the normalized vector representing the forward axis, and importantly, you can get it and you can also set it, so you have both read and write. You can read it to get the current transform forward, but you can also write to it to essentially rotate the transform. So we can just assign this to our forward vector. Also, by the way, you also have transform.up and transform.right. Both these work exactly the same way. For example, transform.right, this one is extremely useful for 2D games, but over here we're working in 3D, so we want transform.forward, and all we need is the forward vector, which is really just the move direction. So let's set this one equals the move there. Okay, so just like this, it should already work. Let's also just clean up the log. We no longer need to see the delta time. Okay, so let's see like this. Okay, here we are, and as I move, and yep, there you go, and look at that, the player object does indeed rotate to face the move direction. Okay, so it's already looking great. All right, awesome. However, it also looks a bit odd with how it's instant. So I move left and right, look at that, it instantly rotates. So there's no smoothing, nothing, it's way too janky. So let's add some nice simple smoothing. And for that, let's use a really awesome, really useful math function called lerp. It helps you interpolate between two values. I made a quick video showcasing a bunch of uses for it. You can lerp floats, vector 3s, quaternions, or just about anything. It's really perfect for making some smooth movement or smooth rotation. So for that, we can access the function inside the vector 3 class, so we can find lerp. Then here we actually have two options. We've got lerp. This one interpolates, and we've got slurp. This one interpolates, but with a spherical interpolation. Basically, if you're dealing with rotations, like what we have here, then we want to be using slurp. Whereas if you're dealing with just positions, then you want to use lerp. So here, let's use slurp. This one, as you can see, takes an A, a B, and a T. Like I said, this interpolates between A and B based on T. So for example, if T is 0, then it will return the value A. If T is 1, then it will return the value B. If T is 0.5, then it will return the point in between A and B. If you want to learn some more about interpolation and the math behind this, then I highly recommend you look at my video on splines. Splines are basically just a whole bunch of lerps put together. So anyways, over here we can add some smoothing to our rotation by just using the current transform.forward as our A. Then for the B, this one is our target, so let's use the move there. And finally for T, let's use time.delta-time. Meaning that with this, over time the character will rotate towards our target movement direction. So just with this, let's test. So here if I move to the right, and yep, look at that, it is indeed rotating. It's way too slow, but yep, it is rotating smoothly. Alright, so let's just add a bit more speed. So over here, let's just find a float for the rotate speed. Let's put it at something like 10f. Then we just multiply it, so time.delta-time multiplied by our speed. Let's see. And move, and yep, there you go, look at that, much better. Okay, great. So as you can see, everything works. As I move, the character does rotate to face the move direction. Alright, great. So here we have our character with a nice visual, all rotating to face the move direction. Now the next step is we want to add some nice animations, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add some animations to our player character. Now, I have already included some pre-made animations with a pre-made animator over here inside the assets folder, but let's first do it from scratch just so you'll learn how to do it. First, to animate, we're going to need the animator component. If we go inside the player visual game object, once again, remember all the visuals go on the visual game object. So for adding the animated component, we want it on the visual and not on the logic component. So anyways, over here, as you can see, by default, I already attached it with the assets included, but let's do it from scratch. So let's remove this by default. Now let's add a new component. Let's call it an animator. Also, one very, very important thing here. It's the animator component, not the animation component. These two are completely different. The animation component, this one is actually related to Unity's legacy animation system from a very long time ago. It's only here pretty much for backwards compatibility and for super simple use cases. So most of the time, make sure you're using the animator component. Okay, so to drive this animator component, we need an animator controller. Let's go into our project files and let's create a brand new animator controller. Let's call this my player animator. Then let's select the player visual and just drag the controller on there. Okay. Again, if you have issues and you cannot drag the animator onto the field, make sure you're using the animator and not the animation component. Okay, so with this, we have assigned our animator controller. And now let's double click on it to open the animator window. And if you don't see it, then go into window, then go into animation and open up the animator window. And also, if you still don't see anything, then maybe you might have some issues with your layout. If that's the case, then go onto the top right corner layout and go back into the default and then back into your own layout. And finally, if you still don't see anything on this window, if you don't see the default states, make sure you have the object selected in the hierarchy. So with that, you should be able to see these states. So this is our animator controller. Now I have a really detailed overview of the animator and the animation windows in my Ultimate Unity overview course. So you can go watch those lectures for some really in-depth explanations about everything this does. Basically, the animator is a state machine. So you have various states and you can create transitions between each state. By default, you have these three special states. There's the entry state, exit, and any state. These are used for making transitions, but we don't really need to worry about them just for now. First, let's just make a basic new animation. And for that, the easy way to do it is to open up the animation window. So let's go up top into window, go into animation and open up the animation window. So here it is. Again, that's a different window. That's animation, not animator. And for me, for this window, I like to dock it down here. So there's a nice timeline. So I think this is good. Okay. And now if we select the object in the hierarchy that has our animator, then we can see the text here. So to begin animating, we've got a nice button to create an animation. So let's go ahead and click on this. And now let's give it a name. For now, let's first make the idle animation. So let's just call this idle. And yep, just like that, we have created an animation. You can see the animation window down here has changed. We now see a nice timeline showing the time. And also on the animator controller, you can see the new animation was added as a brand new state. So a new state was created, and if you click to select it, on the right side in the inspector, you see the motion, so the actual animation selected. And you can also see that there's an arrow pointing from the entry onto the idle state. So that means this one is going to be the default state. When the animator controller starts, it will start playing right on this state. Let me just point out one more thing related to animations. So on the project window, we can see, yep, here is our animation that we just created. And you can see the inspector looks just like this. Now, if your inspector looks differently, that might be because you accidentally created a legacy animation. That has to do with the previous animation system that I talked about, the one that is legacy that should really no longer be used. So if you see a different inspector, then a quick way to fix it is to click on these three dots on the inspector, these three dots. Then you change the inspector into debug inspector. And over here, you see a toggle for legacy. So for the animations that we want to use right now, we do not want to be using legacy animations, so make sure this one is untoggled. If in your case it's toggled, just untoggle it, then go back into the normal inspector, and now, yep, it should look just like this. Okay, so we have our animation, and now it's on our animator controller. Now let's actually make an animation. So let's select the animation window, and again, let's make sure to select the object, so let's select the player visual game object. So here on the animation window, we see this nice little red button. This one enables or disables recording. So if you click on it, you can see, yep, the timeline is now red, meaning that we are now recording. And now we can do anything to any child objects and it will record any changes we make. Now note what I said, that's very important. It needs to be child objects. If you select, for example, the parent game object, then all of a sudden it stops recording. So you can only animate child objects. So let's select the player visual, let's enable recording, then let's expand the player visual. Let's make sure that our timeline is on 0, so drag it all the way to the left. And now for example, let's grab the head object and let's move it just a tiny bit. Basically just move it enough in order to make sure that the position over here is in red, meaning that we have recorded a keyframe. Then let's drag the timeline by a little bit. Let's go over here to frame 30. This one is actually going to be half a second, and it's going to be that because over here on the samples, this is the frame rate for the animation. So at 60, that means we have 60 frames. This makes 1 second, so 30 frames would be half a second. You can also zoom out by scrolling over here or dragging the handles down here. So let's go into 30, half a second, and now this one, let's move the head by a little bit, something like this. As you can see down there, we can note that it recorded the new keyframe. And now if we hit on the play button, we can preview the animation, and yep, look at that, it does do exactly that. So it starts off down and then moves up. Okay, so that's great, but we don't want it to snap back, so let's actually add another keyframe right at the end. So let's stop playing the animation. And to make sure we have a perfect loop, let's just click to select the keyframe. Let's press Ctrl C. Then let's go down into the 1 second mark. Let's press Ctrl V, and there we go, there's the exact same keyframe. So now if we hit on play, yep, there we go, we have our nice seamless loop. So the head goes up and down and repeats forever. All right, awesome. Okay, so that's great. Now let's also do one thing. Let's also record a keyframe on the body. However, we don't want it to move, at least not in this idle animation. We just want to have a static keyframe. So let's select the body. And let me actually move it a bit to the side just to make sure to record. And now manually we can modify the things over here to modify the actual keyframe data. So on this one I don't want it to move, so let's put it all the way back at 0, just to make sure we have a nice keyframe recording. Now the reason why we are recording the body position even without moving it is because the wonk animation will indeed move the body, but when we get back to idle, we want the body to go back to this exact position. So that is why we need a keyframe here. Okay, so that's done, so we can stop recording, so let's click on the red button again. Okay, great. By the way, one more note to make sure that the animation loops, go into the project window, and over here select the animation and make sure loop time is enabled. It should be there by default. Okay, so the animation is set up, and if we look in the animator, it's already the default state. So if we hit play, we should be able to see the idle animation playing nonstop. So let's hit play, and yep, there it is, the idle animation with the head moving up and down. Everything works perfectly. All right, awesome. Okay, so next up, let's make a wonk animation. Now for me, when making an animation that is based on another one, I like to actually duplicate it instead of starting from scratch. So over here on the project window, let's select the idle animation, and let's duplicate it, so Ctrl D. Let's rename this one to the wonk animation. And now if we select the player visual and then we go into the animation window, over here we see a nice little drop down menu for all of the animations, except right now we don't see the wonk animation, we only see the idle animation. That is because this menu only shows animations that are attached to the animator. So first we need to add the animation onto the animator component, and how we do that is actually super simple. Let's just open up the project window and just drag the wonk animation and drop it here. That's it. So with this we have attached a new state to the animator controller, and now if once again we select the object in the hierarchy, go into the animation, click the drop down menu, and yep, now we do see the wonk animation. So let's click to select this one, and now for this one let's make the animation. So let's look in scene view and make it bounce just up and down. So I'm going to enable record, go back here, and for the body this one already has a keyframe, so let's go up here, move it a little bit, and then copy the keyframe, put it the same one at the end, something like this. So there you go, just goes up and down. Let's actually put it offset so it looks a bit better, so something like this. By the way, in a bit we're going to replace these animations with the ones that I made previously, so don't worry about making the animations perfect unless you want to do that. Okay, so there you go, that's the animation, although for walking it should be much faster. So here's a quick animated tip. The stop bar here lets you select all of the keyframes within a certain time. So if I click to select, note how it selects both those keyframes. And also if you click and drag whilst on top of here, you can select multiple keyframes. So for example, to select everything, just click and drag to select all of them. And now you see these nice little vertical bars. So if you click on those and then you drag them, you can basically modify the time of all the animations and everything matches up. So for example, let's make this one super fast. Let's put it just 20 frames. So there you go. Now it's a much faster walk animation. Okay, great. Let's click on the right to stop recording. All right, and back in the animator. So over here we have both animations. And now what we need is to make a transition going from idle into wonk. Otherwise the wonk animation will never play. So how we make a transition is also super simple. Let's right click on the idle state. Let's make a transition. Then now we have a nice little arrow under the mouse. And now if we go into the wonk and click on it, there you go, we have a nice transition. Now we can click on the transition itself to select it. And over here in the inspector, we see a bunch of transition options. So let's expand the settings. Yep, there you go, everything. Now, like I said, I covered all of these options in a lot of detail in my Ultimate Unity Overview course. So if you want to learn more, go watch that. Here, let's just learn the basics for how to achieve our goal in making a simple player animator. The important one is over here, the exit time. Basically, if this one is toggled, then this transition will be triggered automatically, meaning it won't play the idle animation and immediately transition into the wonk animation. So for example, if we hit play and look at it quickly, yep, there you go, there's the idle, and yep, transitions into wonk. And now it stays there forever. Okay, so that's good, but not exactly what we want. We want the wonk animation to only play when the character is wonking, and when it stops, we want it to go back into the idle animation. Now for that, we need to use animator parameters. So back in our animator, on the top left corner, we see something called layers. We don't need to worry about that for now. And then next to it, we see parameters. Then we can click on the plus button in order to create a brand new parameter, and you can see all of the various types that we can create. Now for wonking, we want something that we can set to either true or false. So let's go with a nice boolean. And for name, let's call it is wonky. Again, pay very close attention to the capitalization. This is extremely important. Just like code, is wonking is different from is wonking. So make sure the capitalization is perfect. Okay, so with that, we have our nice parameter. Now let's click on transition going from idle into wonk. And now let's untick exit time. We don't want this transition to trigger automatically. And as soon as we do, we see this nice little warning. Basically, it's telling us that this transition will never happen. So over here, we have the nice conditions. If we click on the plus icon, we can add some conditions. And for this one, we want this transition to happen from idle into wonk when the parameter is wonking is set to true. So that's it. This is our transition. Now let's just do the reverse. So let's right click on the wonk, make transition, go back into idle. Let's click to select transition, get rid of the exit time and conditions when is wonking is set to false. Okay, so just like this, our basic animation logic should be working. So let's test. So here we are, and the character is playing the idle animation. By the way, you can look at the animator while the game is running. So let me just drag the animator window, just drag it and put it on the side of the game view so we can see both at the same time. Okay, great. And right now, note how it's not updating. So there's nothing moving over here on the animator component. That is because, like I said, you must select the object. So on the hierarchy, make sure you select the player visual, and yep, there you go. Now you do see that updating. So make sure the object is selected in the hierarchy. And over here, we see a nice little progress bar showing the idle animation constantly playing and looping. Okay, great. Another important thing is over here the parameters. You can manually change the state of these while the game is running. So for example, if I click, it's going to trigger the is wonking parameter, which should trigger this transition and should go into wonk. So if I click, and if there you go, transitions into the wonk animation, and now, yep, it is playing the wonking animation. And if I click to untick it, look at over there what happens, untick, and there you go, transitions back into idle. All right, awesome. So as you can see, we have all of our logic working. We have the animator with both of our states, and by changing this parameter, we can change which animation is playing. Now, of course, the goal is not to trigger this manually by clicking on it, but rather doing it through code. But at least for now, we know that our animator is fully set up. Again, if you want more detail on the animator and animation windows and everything related to animations, then check out those lectures in my Ultimate TNT Overview course. And also later on, for more advanced use cases, I have a video on the animation rigging package. This one is for more advanced use cases for making dynamic procedural animations. It's really fun, so definitely check it out, but only after finishing this course. That one is a much more advanced tool. For now, let's continue here. So we want to trigger our parameter, but do it through code. And again, here we have yet another clean code question. Technically, we could add that code directly over here on the player script. We could just grab the animator component and change the parameter. And in this case, for this very simple game, that would actually not necessarily be a very bad approach, since the game is so simple with so few animations. But like I said, I want to teach you proper good practices, so let's make it properly and actually separate the animations from the logic. For that, let's go into our project, right click in our scripts folder, create a new C# script. Let's call it the player animator. Let's select the player visual game object and attach the component. Okay, so now here, first let's grab the animator. Now one approach is, like we've seen, we could just make a serialized field and drag the reference in the editor. That's one approach. Or alternatively, since the animator is attached to the same game object as this script, then we can just do a get component. Both approaches are really valid. So here let's use get component just to see a different approach. So we just have a field for our animator, so animator. And then we just do a private void awake. And then awake lets you get component of type animator. And we set our animator variable. Again, like I mentioned, very important, make sure you don't mix animator and animation. These are two different components. We want the animator. Okay, so with this, we have a reference to our animator component. And now how we modify the parameter is actually very simple. We just access the animator, and then we have a bunch of set functions. You can see we have one for each type. So we've got a set bool, set float, then down here a set trigger, set vector. So function to set any parameter type. Now we made it a boolean, so let's use the set bool. And this one, as you can see, takes the name for the animator parameter. By the way, strings are a horrible way of identifying things, but sadly this system really does require strings to identify the parameter we want to change. If you're wondering why strings are bad for identifying things, the reason is because it's very easy to make a mistake. For example, if you use is wonking here, then this will work. However, if you instead write is wonking, then all of a sudden it does not work. If you write is wonking like this, doesn't work, like this, doesn't work. And even though it doesn't work, it will also not throw any compiler errors. That is because for the compiler, a string is a string, it's always valid. But then when the code runs, this one is going to be different than our parameter, which is named the example like this. Always remember that strings are case sensitive. So that's one reason why you should never use strings to identify things. It's very easy to make tons of mistakes that are then again, very difficult to find out. But like I said, in this animated system, we have to use strings. There's no other way. In order to minimize our usage of strings, one thing we can do is, for example, let's define a constant up here. So let's make a private, make it const for a constant, meaning this will never change. Make it of type string and call it isWonky. Again, refer back into the naming rules section. For constants, we always use uppercase, snake case. So isWonky, and let's set it with isWonky. Again, make sure you don't make a mistake here. Make sure you type it exactly like you did on the animator. Then down here, let's use isWonky. And now if we do make a mistake, so if we accidentally use something different, now we do get a compiler error, so at least we have a little bit of protection. Okay, so this one takes a string for the name and then a simple boolean for the value. So this is going to be the value that we want to set to our parameter. Now for this one, we want it to set to true when the player is wonky and false when it's not. So for that, we need to ask the player what it's doing. So let's go over here into our player class. And let's make a function to return just that. So let's make it public because we're going to access it from another script. We're going to return a bool and call it isWonky. Now over here, we just need to return if the player is wonky. So let's make a local field to store that state. So over here, private bool isWonky. Again, note the capitalization. For fields, we start with camel case, whereas for functions, we have Pascal case. So these are different, okay? So basically, in order to define if we are wonky, that's very simple. It's just down here we have the movement direction. So we are wonky if the move direction is different from vector3.0, which by the way, vector3.0 is just a shorthand for writing 0, 0, 0. So if the movement direction is different from 0, then we are indeed wonky. So we define that, we update that field on every update, and then over here we just return it, okay, just like this. And now back in our player animated component, over here first we need a reference to the player. So let's add it here. Let's add a serialized field of type player. And we need to compile this in order to drag the reference. So let's just comment out this line just to make sure the code compiles. Now here with the code compile, let's drag the reference of our player. Okay, that's it. And then over here for the animator, set isWonky. Let's go into the player and let's ask isWonky. And of course, we don't want to do this just on awake. We want to do it on every single frame. So let's do a private void update. And on update, let's do this. All right, that's it. So this should be working. Let's test. So here we are, starting off as idle, and now as I move, yep, there you go, it is playing the wonky animation. And now if I stop, and yep, there you go, back into idle. All right, awesome, everything does work perfectly. Okay, great. We can even look at the animator to see the state change. So here with both side by side and with the object selected in the hierarchy, right now you can see isWonky is false, so it's on idle, and as I move, that one stays true, that one goes into wonk, and now if I let go, if there you go, back into false, back into idle. All right, awesome. So with this, everything is working perfectly. If you're having issues, make sure you pay attention to the capitalization. So make sure the name you wrote here is exactly the same one that you wrote here, and it's exactly the same that you're using here. All right, so all of our animations are working perfectly. Now, if you want, you can go ahead and make your own animations, or you can use the ones that I pre-built. So in the included project files, inside the assets here, we've got the animations, and we've got the player with the idle and the wonk animations. If we double click on this to look at it, you can see, yep, it looks exactly the same. So there's a parameter called isWonky and our transition, so everything is exactly the same. Just over here, let's select the player visual, and on the prefab, like we saw, we already had the animated component. We just removed that one from the prefab in order to build it all from scratch. But if you want to use my animations, then we can just go ahead, remove the animator that we added, and then right click on this one on the remove component. Let's revert back the changes. And there you go. Here we have our animator with the player controller. So that's the one in the included animations. And just like this, if we had on play, and actually over here I found an issue, although in your case there shouldn't be any issue because I have updated the assets. But this is a good time to teach you about any issues with animations. So if you select the animation and you select the animation, then over here you might see some of them in yellow saying missing. Basically the way that animations work is based on the actual name of the object. If it cannot find an object with the exact same name, then it cannot load the same animation. So my problem is that when I initially made the assets package, I made this animation and the object was previously named face, and then I renamed it to head, so now it no longer loads. So if you ever have problems with loading animations, just make sure the names perfectly match. So in my case, I can just click in here in order to rename this keyframe on the animation. And I'm just going to use the name that I renamed it. So head, and just like this, yep, the animation does play correctly. So just a nice quick tip, if you ever have problems with animations, always remember that the stored keyframes, they're all stored based on name. So if you rename the thing in here or over here on the game object, if you rename, you're going to have missing animations. But if you make sure the names match, then the animation should load perfectly. So let's hit on play. And if there you go, there's the idle animation. And if I move, yep, there's the nice wonk animation. So everything still works perfectly because it's only using the exact same parameters. All right, awesome. So like I said, if you want, feel free to make your own animations or use the ones that I've included. For me, I'm going to be using these ones. So the ones that we made just for learning, which I created down here, so the My Player Animator and these animations, I'm just going to delete these just to keep the project clean. So just delete, and just like that. Okay, so now that we have our character fully working, let's quickly handle our camera. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to quickly install Cinemachine. This is a Unity tool that makes handling cameras super easy. Our game isn't really going to have a moving camera, so this part isn't strictly necessary, but Cinemachine is a super useful tool, so I definitely want you to learn about it. Okay, so let's begin by installing the package. Let's go into Window, open up the Package Manager. Then up top, let's make sure we are in the Unity registry. Make sure you're on the Alt tab, and now just scroll down until you find, yep, there it is, Cinemachine. Okay, so let's go ahead and install this. Alright, it's installed, so let's close this. And now the way that Cinemachine works is by creating what is called a Cinemachine virtual camera. So let's go up top into the Game Object menu, then scroll down into Cinemachine, and over here you can see that we can create a multitude of virtual camera types. Now, just by the names, you can see how this tool is insanely useful. For example, making a FreeLook camera. Doing that from scratch is a bit tricky, but with Cinemachine it is super easy. For our case, like I said, we want the absolute most basic thing possible, so let's just create an empty virtual camera. Okay, that's it. This creates a virtual camera over here in the hierarchy. In turn, this object has the Cinemachine virtual camera component. And also importantly, when we added this, it also added over here on the main camera. If we scroll down, we can see it has a Cinemachine brain component. Basically, the way Cinemachine works is it works on top of the main camera, so it doesn't replace it, it works on top of it and drives the main camera. So now that we're using Cinemachine, if we try modifying the main camera game object, so for example over here, if I try to drag the field of view, nope, does not work, I cannot move it. If I try to move the position, nope, can't do it. If I try to rotate it, nope, that does not work. Like I said, when working with Cinemachine, the Cinemachine brain is what drives the main camera. So rather than modifying the things over here on the camera itself, what we need to do is change them on the virtual camera. So over here we have pretty much the exact same options that we have on the main camera. For example, modifying the FOV, over here we've got the lens, so we can modify the FOV, and if we look in the game scene, as we modify this one, yep, it does modify the actual properties on the actual main camera. Now this has tons and tons of options related to everything. The most important ones are all kinds of options down here for the body and the aim. So this is where the camera is positioned and where it's looking at. Using this, you can make a follow camera in 5 seconds. It really is insanely useful. If you want to learn about Cinemachine in more detail, I have a dedicated video on it. I go through what all of these options do. Then I also have another super detailed video on how to make a camera system with pan, zoom, scroll in both 2D and 3D and a bunch more features. Again, all of it using Cinemachine. But in our case, we really want to keep it simple, so let's just position our virtual camera on the same settings that we had previously. So first, let's set the field of view. So for our game, we want something narrow, so let's go with just 20. Then for the position, let's put it above. So 0 on the X, then 21.5 on the Y, and minus 21.3 on the Z. Then for the rotation, 46 on the X, and then 0 on the others. Okay, so our camera is positioned in the exact same position. And if we head on play, yep, everything still works the same. The camera is looking from the same point of view, and the character still works. Everything's still exactly the same. Now, since we're using Cinemachine, we can easily add some things on top of this. Like for example, we can add some noise to our Cinemachine camera to make it smoothly move a little bit. This one is a fun, simple effect that can make our game feel a bit more dynamic, especially in games like this where we have a fixed overhead view. How we do that is over here on the Cinemachine virtual camera, we've got a field for noise. So let's click and let's select Basic Multi-Channel Perlin. And then over here, we've got the noise profile, so we can choose one of the included ones, or we can create our own profile. So for example, let's go with handheld, normal, mild. And by the way, you can actually modify these settings while the game is playing. So here it is, the game playing, and you can see what this effect does. It adds a nice little wobble to the camera. And then over here, amplitude and frequency, so we can play around these. So you can make it really intense, so something like this, that is way too intense. So there you go, quite a lot. So for something more subtle, maybe put 0.5 and 0.5. There you go, just a slight little movement in the camera. So this would help make the game a little bit more dynamic, so this could be a fun effect. Although actually in my case, in order to make sure that the video doesn't get way too compressed, I'm actually going to disable this on my end. So just set the channel noise to none. But you can see how easy it is to add complex camera features when using Cinemachine. And of course, when using Cinemachine, if you want, you can use it to make your game a lot more unique. Now for me, I want to design here where the camera is fixed. But let's say, for example, you wanted the camera to actually follow the player. Like I said, go watch that dedicated video to learn all about Cinemachine. But over here, very quickly, let me just show you how to do that. But at the same time, don't bother following this part. It's just to show what Cinemachine can do that I'm going to revert back to this state. So first of all, for testing, one great thing about Cinemachine is you can have multiple virtual cameras. You can have as many as you want. And then the priority and the game object enabled state is what defines which camera is actually being used. So for example, on this second one, let's make it follow the camera and put the priority on 20 so that it's above. Then over here for the body, I'm going to select transposer. Let's put it with world space. It requires a follow target, so let me drag the player as the follow target. and put it slightly above and behind. Okay, so it's pretty similar as before. Then for the aim, let me also drag the aim player target. And just with this, it should already work. So if I head on play, yep, there you go. Look at that. The camera is now moving and following the player, so I can move the player anywhere. And yep, the camera follows along. So as you can see, it's this simple to really make some complex camera movement. Doing some complex camera logic just like this would require a ton of work manually, but with Cinemachine, it is super easy. Then you can even play around with either priority or enable and disable. And there you go, Cinemachine even transitions between the state of all your virtual cameras. So as you can see, lots and lots of things you can make with your camera very easily, all thanks to Cinemachine. Like I said, in my case, I just want a fixed overhead camera, so I'm just going to delete this secondary virtual camera. And there you go, just this one on top, looking at the player, looking down with a low FOV. And yep, this is exactly the kind of camera that I want for my game. Okay, so that's Cinemachine. It's a really awesome tool for making camera handling much easier. So this was a quick lecture all about learning about Cinemachine. Now let's handle the test that was actually left undone quite a while ago. Let's finally learn how to refactor code and implement the new input system. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to refactor our code from the legacy input manager onto the new input system. So the simple character controller that we made is working perfectly fine with the legacy input manager. Like I said, this one is excellent for making quick prototypes and demos. As you can see, it's super easy to use. But now let's quickly refactor this code to use the new input system instead. Also, like I said in the beginning of this course, here I'm going to be focused primarily on building this game. So for example, for any Unity tools that I use, like the new input system, I'm going to cover enough to be able to use the tool and achieve our goals in building this game. But of course, every tool does a lot more than just what we're going to use. So definitely make sure to watch the dedicated videos linked in the description. For example, the input system tutorial is 40 minutes long, covering everything you need to know about system, whereas here we're just going to learn enough to know how to use it. So let's refactor this code to make it work with the new input system. Except before we work with the new input system, let's just refactor this code so we can completely decouple the input from the player class. Again, we want to focus on writing good, clean code, so we should keep all of our input logic in its own class that other scripts can access. Remember, the goal with clean code is to minimize and manage complexity. So every class should do one thing and just one thing, meaning that the player class should only handle the player, and then the input class should only handle the input. The only reason why I put this over here in the beginning is exactly to teach you about refactoring and how it's a very common thing that you should be doing all the time. This is exactly how I build my own games. I start by making a prototype and I write the input directly inside the player class, then at some point I refactor the code to split them up. So don't be afraid to refactor code, it's a perfectly natural part of the game dev process and actually a very good thing. Okay, so let's make a script just to manage our inputs. Let's make a new C# script, call this game input. Let's create an empty game object, give it the same name, input. As always, keep things clean, so put it on 000. Let's attach the script and open. Okay, so here's our script and let's get everything related to the inputs. On the player for the input, we are calculating the input vector, then getting the actual inputs from the keyboard and returning the input vector. So let's put this on the other script. So over here, let's make a new function. Let's make it public since we want to access it from the player. We're going to return a vector2 and let's call it getMovementVector. Now here, let's really just copy paste the exact same code that we have on the player. So let's copy paste all of this. Let's go and paste it here. Okay, so we get the input vector, we get the inputs, we normalize it, and then return the input vector. Okay, so that's it, super simple. Also, by the way, here we have an interesting question, which is, do we normalize the input over here, or do we do it over here on the player? Both options can be valid. You can make it so that the game input class returns a regular input, or you can make it return a normalized vector. You can use either option, but whatever you do, make sure you are explicit. So over here, I am going to normalize the input inside the game input class. However, I'm also going to make sure to rename this function. So instead of getMovementVector normalized. That way it is 100% clear. This returns the movement vector as a normalized vector. Okay, great. So now let's use this in our player. Over here in our player class, we need some reference to our input class. Now, later on in this course, I'm going to teach you about the singleton pattern, but for now, let's just do a simple direct reference. Again, remember, don't make it public, make it a serialized field private. So over here, let's make a serialized field private of type game input, and let's call it just game input. Okay, so we have this, we're going to drag it in the editor, then over here, we simply grab the vector2 for the input vector, we simply go into this one, and we get the movement vector normalized. And okay, that's it, no more errors. Let's just make sure to save all of our scripts. And back in the editor, let's go into the player and just drag the reference for the game input. Okay, so just like this, everything should still work. Everything should work exactly the same as previously. Let's test and make sure. So here we are moving, and yep, everything still works. I can move in any direction. Okay, so far so good. And what we have done here is essentially we have refactored our code and completely separated the input from the player class. This is an excellent thing, so again, don't be afraid to refactor code. Also, what we did here of putting the code in a separate class and then doing a quick test to make sure that everything still works the same as previously, this is exactly what you should do whenever you do some kind of reorganizational refactoring. In the end, you want to end up with the exact same behavior as previously, just with the code organized in a different way. Okay, so now that we have this separate game input class, now we can very easily refactor the legacy input manager onto the new input system. So the first thing we need is to install the package, so let's open up the package manager. Let's make sure up here we are in the Unity registry, make sure we are in all, and let's scroll down to find the input system, so here it is. Let's go ahead and install. Okay, the package is installed, and right away we see this message. Basically, it's asking us if we want to enable the new input system. Now, you could click on yes, but let's actually go ahead and click on no. We're going to enable it manually, so click on no. Then let's close this window. And now let's go up here into edit, then let's go into project settings. Then on the left side, let's go into player. And now let's scroll down, expand over here the other settings tab, and keep scrolling down until we see, yep, here it is, the active input handling. This is where you can select which input system you're using. Basically, if you click yes on that window, it would automatically set this option to use the new input system. So it would only enable that one and completely disable the legacy input manager. But like I said, the legacy input manager is still pretty useful, so normally for me, I prefer to enable both of them. So let's go ahead, click on both, and this will restart the editor. So okay, let's go. Alright, the editor has restarted, so now the new input system is now enabled. Okay, so the way that this system works is by creating something called an input actions asset. So on the project files, let's click on the plus icon, let's create something, and let's find the input actions. So we need to scroll down here, so click on the little arrow to go down and find the input actions. Creates this file, let's call this the player input actions. Okay, now let's go ahead and double click on it. And yep, there you go, out pops out the input system window. Basically, this one is where we're going to manage all of the settings for all of our inputs. Also, by the way, like I've mentioned, if you're watching this in the future and for some reason the input system got a new update and changed this window, if so, make sure you check the pinned comment. I'll keep it updated with any changes on anything in this course. So over here, we've got the action maps, then we've got the actions, and then we've got properties. Now, action maps are how you can have different maps. For example, one action map would be for the player whilst walking normally, and you could have another one whilst driving a vehicle. Then for the individual actions in each action map, and finally the properties for each action. Again, if you want to learn about the entire input system itself in more detail, go ahead and watch my dedicated video on it. In order for this course to not be 20 hours long, I'm really only going to use enough to make sure that we can achieve our goal. So over here, we just need one action map, so let's click on the plus icon. Let's name this the player. And now for the actions, right away we have a new action. So let's just rename this one. Let's call this action move. Then with this action selected, over here on the action properties, we can select the action type. Again, in the dedicated video, I cover what all of these mean. For movement, we do not want a button. We want movement in multiple directions, so let's go with value. Then over here for the control type, for this one, let's go with a vector2. And then let's expand our action. Over here, we can see our bindings. However, we don't want this default binding, so let's actually delete this one. Instead, let's click on the plus icon, and over here for the type, first for the keyboard, let's go with this one, up, down, left, right, composite. So this one adds essentially 4 bindings. Let's go ahead and name this WASD. Then for the up, let's select the binding. So over here on the path, let's click on it. Then we can either find it manually over here or click on the listen, and now press the W button. Yep, there you go, W. Then for down, let's go ahead and listen S. Then for the left, listen A. And for the right, let's listen D. Okay, great. So with this, our input asset is correctly set up. One thing you must never forget is up here, make sure to save the asset. You can see this little asterisk here. That means we have unsaved changes. Also, alternatively, there's an autosave there. But for now, let's just manually save the asset. Okay, great. So now let's see how to actually use this in our code. There are many ways we can use the input system. One way is by using the built-in player input component. So for example, on the player, we would add the player input. So you could add this one, attach an input actions asset. So this is our player input actions. Then over here, we have various behaviors in order to be able to trigger our actions. But in this course, like I said, I'm going to be using the exact same code quality that I used in my own Steam games, so I will not be using this component, so let's remove this. Instead, I will be using the native C# method. So let's select the player input actions, and over here on the inspector, we see this nice toggle to generate a C# class. Let's go ahead, enable it, and for these fields, we can leave them all on defaults, that's okay. Let's just go ahead, click on apply, and now it's going to generate those scripts and compile them. Okay, great. Basically what this is doing is auto-generating some C# code, and on the player input actions we can see over here, yep, we've got the generated script. If you want, you can even open this to see all of the source code. Now all of this, like it says here, this was all auto-generated, so don't make any modifications here. If you change anything, any manual changes will be lost when you save some changes in the input asset. So if you want, go ahead and read through in order to see how all of this works. But in order to use it, it's actually super simple, you don't need to worry about this script. First thing we need is to construct our script class that was auto-generated, so let's do it over here in our game input. Let's make a private void awake, and on awake let's construct it. So let's do a new player input actions. So we construct an object of this type. So we have this, although just like this it won't be active, so we need to manually activate whatever action map we want. So let's go inside and let's go inside the player. So this is the action map that we created, and let's call enable on it. Okay, so just like this, it's really already working. All we need to do is modify our code over here on the get movement vector. So for that, we're going to need to access this. So let's actually make this a member variable. So private, let's store it up here instead of making a local variable in here. Okay. So we have this one, and then down here on the input vector, let's go inside the player input actions, inside the player action map, and then we called it move. So we've got this one. And then we defined it as a vector2. So over here we can call read value. And this one takes in the type of the value. Now we defined it as a vector2, so let's read it as a vector2. And just like this. This returns a vector2, which is really going to be our input vector. So let's put it exactly like this. And we can now get rid of the rest of it. Alright, so that's it. And just like this, we should already have everything working exactly the same as previously. So let's just do a debug.log just to make sure. So let's test. So here we are, and the output is 0, 0. Now I press W. There you go, +1, -1, left, right, and all of the ones in between. All right, awesome. So we have the new input system, all of it working flawlessly. Also, by the way, over here we can normalize the input just like we were doing previously, so we do it over here through code. Or alternatively, we can also go into the player input actions, and over here there's something called a processor. So you can go into this action, add a processor, and make it normalized. So these processors here can be quite useful. I cover them all in detail in the other dedicated video, but over here let's stick with making it through code that works just as well. Okay, so that's our refactoring done. With that simple change, we are now using the new input system. So you can see how by refactoring our code to make sure to use the game input class, when we change from the input manager onto the new input system, when we made that change, we did not have to touch the player class at all. The player class just has the game input to get the movement vector and does not care what system he uses to get that. So here we have a very practical, very excellent example of the power of writing good, clean code. Because we separated things correctly, we managed to change something completely and not have to make any changes on any other class. So now that we're using the new input system, let's just quickly see one of the main benefits of this system, which is easily supporting gamepads and more keys. For example, a lot of people like using WASD, but some people also like to use the arrow keys. With this system, that is super easy to add. So let's go into the move, let's add another one. Let's add another one, up, down, left, right composite. Let's call it arrow keys. Then let's just put them. So let's listen on the up arrow. Then over here we've got the down arrow. Then we have the left arrow. And finally we have the right arrow. Alright, so we've got all the arrows. And now we don't even need to touch any code at all. Let's just make sure to save the asset, which again, in turn, that is going to auto-generate the C# class and going to compile. Okay, so we don't need to touch any code at all. Let's just hit on play. And now if I move, we're using the WASD keys, yep, still works. And if I go into the arrow keys, yep, also still works. All right, great. Now for another one, let's make it for a gamepad. So I just connected an Xbox controller, and we can see over here on the log, yep, the game did identify it. So this is the new input system in action. Let's once again open up the input actions. And over here on the move, let's add another one. And this time, let's just make it a regular binding. And now over here on the path, once again, if we want, we can go down here and specifically find some joysticks. So you can find any of them, or once again, let's just use the listen. Now I'm just going to move the thumbstick on the controller. Yep, there it is. And now if you wanted, you could go specific and make it just work with Xbox controllers, or you can just use the generic left stick. This will make it work with an Xbox controller or a PlayStation or really anything. So let's go with this one. And that's it, nothing else we need to do. Let's just save the asset and that's it. We don't need to touch any of our code to make our game playable with a controller. So let's go ahead and test. So here we are, and first of all, if I move the keys, yep, still works. Move the arrow keys, yep, both of them works. And now if I use my gamepad, and yep, there you go, everything works perfectly. Alright, awesome! So as you can see, this is one of the main benefits of the new input system. It makes handling different inputs really super easily. As you saw, we didn't have to touch our code at all. We just had new bindings, and just like that, our game is playable with all kinds of inputs. So here you can really see just how powerful new input system is. Okay, so with this, our basic character movement is working great. We can walk around, everything looks great. Now in the next lecture, let's apply some collisions to our player. Hey again, here's another quick intermission. I hope you've already learned a ton from the course. Have you seen the benefits of writing good clean code? Has the course already helped you understand some more advanced concepts? I really hope the answer is yes to both of those. Remember to follow the website page as you follow along. I will be adding frequently asked questions to every lecture. If you ever get stuck, you can just download the project files for a lecture and compare with your own. And definitely check out the related videos when I reference them. This course is focused on making this game, but you should definitely learn more about some of these concepts in more detail, and you can learn that in the videos that I mentioned. By the way, if you're watching this right now, this is the secret callout, so go ahead, post a timestamp in the comments with a nice monkey emoji. I want to see how many people make it this far. Okay, so that's it for now. Let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to apply some collisions to our player movement. Okay, so here we have our game so far. We have our player walking around and everything looks pretty good. However, now let's create over here in the hierarchy, let's right click, create a brand new cube. So there you go, let's place it over here and push it down. Okay, there's the cube. Make it just a little bit bigger. So there's the cube, and by default it has a box collider component, so it has physics. And the player, if I move, and nope, there's our issue. The player is going right through the object. Now the player is not meant to be a ghost, so let's fix this. Over here in our player script, we are carrying the input vector, calculating the move direction, and then just moving the transform. So right now we're moving it no matter what. Now before we do that, let's first do a test to see if any object is in the way. And how we're going to do that is by firing a raycast. This one is a physics operation that basically fires a laser from a certain point towards a certain direction and then tells you if it hits something. How we do that is let's go inside the physics class and let's call the raycast function. This one, as you can see, has many versions of this function with all kinds of parameters. Let's use this one, option number 7, which takes a vector3 for the origin, a direction, and a max distance. So first for the origin, that is from where we want to fire our raycast. Let's put the player object in, so that's transform.position. Then for the direction, this is going to be our move direction, so let's use our move there. And finally for the distance, let's use some kind of player size, player width, something like that. So let's define up here a float for the player size and put it at 0.7 units. Let's try out with the size just like this. Okay, so basically this returns a boolean. It's going to return true if it hits something and false if nothing is in the way. So let's just do a bool, call it can move, and basically we can move if this raycast doesn't hit anything. So we can move if this one is false. So if the raycast is false, then can move is going to be true. That's very simple. So if we can move, then we move the transform position, otherwise we don't. Okay, that's it, super simple. Let's test. So here we are, I can move around, and if I go towards the cube, and nope, no longer works. So I can no longer go inside that cube. Okay, great. Now in your case, if it's not working, first of all, make sure that the cube, make sure it is touching the floor. We use the transform position as the origin, which is right on the floor. So if the box is raised up, then you won't be able to go through, so make sure the cube is touching the floor. Also make sure the cube has a box collider component. It can be any type of collider, but if you made a cube, then it should have a box collider by default, and it should have the same shape as the visual. And also remember that the 2D and the 3D physics systems, those are completely separate. They are completely different worlds. So make sure you're using 3D components and not the 2D ones. So for example, if I add box collider 2D, if I add this one, then it will not work. So make sure you're using the 3D and not the 2D components. Same thing over here on the script, make sure you're using physics and not physics 2D. Also finally, if you're still having issues, make sure you check the player position. Again, the player should be on a Y of 0. The only thing that might have an offset is the player visual, although if you're using the same as me, then this one should also be on a Y of 0, so all of these on Y of 0. And then you can also check the floor. By default, this one has a mesh collider, but if it is exactly on Y of 0 with no rotation, then it shouldn't cause any issues. Alternatively, you can also just disable or remove the mesh collider from the floor, since we're not going to need that. So with all of that, yep, everything works. I can move the player, but I cannot go through solid objects. Alright, awesome. So it is working. But for this particular use case, a raycast isn't necessarily the best method we should use. Basically, a raycast is, like I said, kind of like a super thin laser. But as you can see, the player visually has an actual body shape. So the visual and the logic are using completely different shapes. If I go ahead and push towards the box, you can see it works just fine. However, if the player is a bit more off to the side, and the center of the player right in front of it is not the box, and I move, and yep, there you go, now I am going through the box. The reason is because the raycast is being fired from the center of the player, and like I said, it's kind of like an infinitely thin laser, so it has no shape. So as long as the center of the player is not hitting the box, then it can go through it. Whereas what we really want is for the visual and logic to have pretty much the same shape, so let's not use a raycast. Over here on the code, instead of a raycast, we can use a physics query with an actual shape. There are all kinds of casts you can use. And as you can see, all of them with different shapes. So you've got a box cast if you want to have a box, a capsule if you want a capsule, or a sphere cast. All of these work pretty much the exact same way, except instead of a raycast which fires an infinitely thin laser, these are going to have an actual shape. And for player controllers, for the most part, you really want to be using a capsule cast. That's usually the generally accepted player shape, although alternatively a box cast also can work very well. In our case, let's just go with a simple capsule cast. This one, to define a capsule, has a 0.1 and a 0.2. By the way, if you have no idea what is a capsule, then we can go over here in the hierarchy, let's right click, create a 3D object, let's make it a capsule, and there you go, this is a capsule. It's kind of like a stretched sphere. So it has rounded top, rounded bottom, and then over here in the middle, it's just a cylinder. And over here for the raycast, takes a 0.1 and a 0.2, so that is going to be the bottom of the capsule and the top of the capsule. Basically, with those 2 points, we can define the height of the actual capsule. Okay, so let's just get rid of this capsule, let's just delete it. And over in the code, let's put those. Now for 0.1, it is indeed going to be the transform dot position, since that is the point at the bottom. And for the second point, for this one, it's essentially going to be the player head. So we can take the transform dot position, so this is the bottom, and we can essentially just lift it up. So let's add a vector3 dot up and multiply by some kind of player height. So let's define up here a float for the player height. And I tested it in the editor, and the player is about 2 units tall. So over here, let's go ahead and move it up by that much. Okay, so next we want the radius. So this is pretty much the player size that we defined previously, so let's use the same thing. But as always, let's make sure to write good clean code. Since now we are referring to a radius, let's actually rename this to be a bit more clear. And by the way, here's a quick Visual Studio tip. You can right click on a symbol, and then you can click on the rename option. Alternatively, use the shortcut Control R. If you do that, then now you can change the name. So for example, player radius, and note how it changes every single instance of that variable. So this renaming feature is extremely useful. Always make sure to rename something if you find a name that works best. Okay, so let's rename this to player radius. Then we have direction, so that is as usual going to be our move direction. And then finally we have the move distance. For that we can use the actual move distance. So that is going to be the movement speed multiplied by time.delta-time. So I just find here a float for the move distance. And we just do that, just move speed, time.delta-time. We have the move distance, and we use it both in here as well as down here. Okay, so here we have our capsule cast. The rest of the logic is exactly the same, so if this one is false, that means it didn't hit anything. So if it didn't hit anything, then we can move, and then we move the transform. Okay, let's test. And over here, now if I go towards the box, and yep, still works exactly the same as previously, that's great. And now if I go towards the edge, and make sure that the center is not hitting the box, and now I try to move forward, and nope, now we no longer go inside the cube. So even on the edges, everything still works perfectly. Alright, awesome. So it works, it looks good, but it also is a little bit janky. For example, let's stretch this cube out a little bit, so let's put it just on one direction, so stretch it like this, let's see. Now if I move towards it, then nope, I cannot go through it, so that is correct. And if I move left and right, yep, that's also correct, that works. However, if I now press W and D at the same time in order to move diagonally, and nope, right now it does not move. The reason is because the diagonal vector, that one is indeed hitting the collider. But usually in games, when you move diagonally and you cannot move in one direction, then it tries to essentially hug the wall and move around it. So if I press W and D, it should essentially be moving straight to the right. So let's solve that. So here in our code, we're making our capsule cast. Okay, that's great. Then we need to test if we cannot move. So let's do if we cannot move. So if can move is false. If so, then that means we cannot move towards this direction. And if we can't, then essentially we basically want to split the movement direction and just move on the X or just on the Z. So first, let's attempt just the X movement. So attempt only X movement. Let's create a new vector 3. Let's call it move dir X, and we make a new vector 3. Let's take in the move dir.x, then 0 on all the others. So we only want to test moving in the X direction. And then let's do literally the same thing. So let's get our can move, try to move under this direction. So let's go instead of move dir on the X. So we do that capsule cast. And if we can move, then that means we can move only on the X axis. So can move only on the X. And if so, let's set the move dir equals the move dir X. So if we can move, then down here when we use the move dir, we're going to move only on the X. And if we cannot move, then that means we cannot move only on the X. And if so, then let's attempt only Z movement. So over here, again, let's do the exact same thing. So let's copy this. Let's just change this one. So instead of move dir X, we've got move dir on the Z. So over here, we use 0 on the X, 0 on the Y, and access the move dir and get the Z. Then let's use this movement direction over there. And finally, the same thing. So if we can move, then that means we can move only on the Z. And let's set the move dir equals the move dir Z. And if not, then we cannot move in any direction. Okay, so that's it. Now this might seem a bit confusing, but it becomes a lot more clear when you see it in action. Again, remember the scenario we're trying to solve, which is when moving diagonally. So for example, when we're moving forwards and to the right. If we do that, then let's say this one is going to hit something, so we cannot move. So if we are trying to move both forwards and to the right, then we're going to only attempt the X movement, so we're only going to try moving to the right. And then we're going to see, yep, going to the right, that does work, so we can move, and we're going to move just to the right. Alright, so let's test and see if all of this is working. Alright, so here we are, and if I move straight to the wall, and nope, there's a limit, so I cannot move anymore. Okay, great. Now if I move just left and just right, then it does work. Now if I press W and then D, and yep, there you go, now it does hug the wall and continues to move. Same thing if I go on the left, so over here if I press D, no I cannot go through it. Now if I press D and S at the same time, and there you go, it hugs the wall and moves around it. So now our controller is much more easy, much more understandable. Okay, so this is great. Now this is one of those tiny things that makes your character controller feel much more responsive, so that's great. However, we also do see one more issue. Right now you can see that I'm right next to the wall, and if I press A and D, then look at that, I'm moving with this speed. However, now if I press W and D, look at that, now I'm moving diagonally and it's actually moving slower. Basically, this is the same issue that we saw previously where we had to normalize the input so we didn't go faster in diagonals. Basically, now we have the opposite problem. Since we are normalizing the vector, we are cutting down on the left-right vector. And with that, basically, if we are moving diagonally, then we are essentially going slower, whereas if I stop moving diagonal and just move left-right, it moves at a different speed. Now, the solution for this is really super simple. Over here in our code, when we are constructing the move dir X and move dir Z, when we do this, very simple, let's just normalize it. So if this one is less than 1, then it will be going into 1. So let's normalize that one and that one. Okay, that's it, let's test. And now if I'm here, move forward and hug the wall left-right, yep, it does work. And if I stop moving diagonally and just go left-right, yep, all still works with the exact same speed. All right, awesome. Okay, so that's really it. As you can see, it's super simple to add collision detection to your movement scripts. You just do a physics query to test if our character should move and just move it. By the way, if you want to learn more about collisions and physics queries, there's a bunch of interesting videos that you can watch. For example, one is on various methods of finding a target. Then another one is on various methods of handling projectiles. And finally, another one is a very quick checklist on why collisions are not working. Basically, there's lots of really interesting things you can do with physics, so make sure you understand these functions. Okay, so now that we have all of this working, let's first just clean up our scene. So over here, our default cube, we don't want this, so let's just get rid of this. And with this, we are ready to build our first kitchen counter, and let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to begin building one of our main game mechanics. We're going to make a kitchen counter and handle the logic for the player to be able to interact with that counter. Okay, so let's begin by making our kitchen counter. And just like we did when we made the player, let's first make an empty game object and place the visual inside of it. So let's right click on the hierarchy, create an empty game object, call this the clear counter, so it's going to be clear on top so we can place and pick up objects. Let's make sure to reset our transform, so let's put it on 0, 0, 0. Let's move it just a little bit, just so it's not exactly on top of the player. Okay. Now inside, let's add the visual, so let's go inside the assets folder. And then over here, we've got the prefabs visuals, and inside we've got the counters visuals. And over here, let's find the clear counter visual. So let's go ahead and drag it inside the game object. Again, make sure the child visual is on 0, 0, 0, the local position. Okay, great. Now, just like we did in the last lecture, where we added collision detection, that should already be working by default, but in order for it to work, it needs a physics collider. However, note how the visual over here, there's no collider, and inside there's no collider, there's only visuals. Again, this is the same thing that relates to separating logic and visuals. Basically, the visual prefab, this one only has visual components, so only meshes, animations, and that sort of thing. And the main parent game object, this is the one that is going to have all of the logic components. So that means any kind of scripts behavior as well as any colliders. So over here on the parent game object, let's add a new component. Let's find a box collider. Again, make sure you add a box collider, not a box collider 2D. And I chose a box collider just because this is the shape that makes most sense for our counter. And now let's scale the box collider. Again, that's the box collider, not the transform, so leave that one with the scale of 1, 1, 1, that's good. And over here on the box collider for the size, let's put it up with a size that fits the visual, so 1.5, 1.5, 1.5. And finally, we just need to lift it up a bit. Over here on the scene view, you can see those little green tiny lines. These refer to the box collider shape. So let's lift it up by a little bit in order to make it perfect. Let's put it up by 0.5 on the Y. All right, so there you go. That one does have the perfect shape. If we test just like this, it should already be working. So okay, so here's my player, and if I move towards it, and yep, there you go, it does work. So it is a solid object, I cannot go through it. Okay, great. Let's just visually rotate the collider. So let's do that, and again, for rotation, let's make sure we rotate the parent game object and not the visual. We want the visual to be on rotation 0, 0, 0. Okay, great. So on the parent game object, let's just rotate it around. By the way, here's a quick Unity tip. If you want to rotate, hold down Control and then click to rotate. And now instead of rotating on every angle, it goes on a 15 angle increment. So just hold down, and this way you can easily get it to 180 degrees. So that's just for fun, just to make it face the player. Okay, great. So now let's interact with this counter. And doing this is actually super simple. We already learned how to do a raycast to handle collisions, and for interactions, that's exactly the same thing. So let's go into our player script, and we're going to do a raycast to handle that. But before we do, let's organize our code here. Let's make a proper function to handle our movement. So let's make it private, since this is going to be a local function. Return void and call it handle movement. And then inside, let's put all of this code. So let's copy all of this, put it in there, and then on update, we simply call this function. Okay, great. And now let's make another function. So private void, let's call it handle interactions. And we just call this function on our update. Okay, great. Everything is much more organized. So now here, let's do a raycast. So once again, go inside physics, do a raycast. For the origin, let's start on transform.position. For this, obviously, we want the move direction. So one approach would be to make this a field variable sorted up here, so that way we can access it in both functions. However, if you remember how we handled the whole issue with the diagonals, basically we're modifying the move direction. So if we're moving diagonally, then this one modifies to only move left or right. We don't want that for the interaction. We want pretty much the exact same one, even if it's pointing towards a solid object. So let's not make this a member variable and reuse it. Instead, let's just grab it again, create it again over here. So we get it, and we want this one even if it's pointing towards a solid object. So let's use this as our move direction. And now for the distance, let's define a fixed distance. So something like 2 units would work. And also here's another very important lesson with regards to writing good clean code. So you would think to write code like this. So let's put the 2 right in here. That would work, everything would work perfectly. But then let's say you get back to this code after 1 week. Would you remember what this 2f means? The answer is probably not. You would probably very easily forget exactly what this means. So because of that, you should never use numbers directly in the code like this. Instead, you can either make a field up here if you want to make it customizable, or much simpler is actually what we already did previously. So let's define a local variable with a proper name. So let's define a float, and this one is going to represent our interact distance. So let's call it exactly that, interact distance, and let's put 2f. And over here, instead of using a number, let's just use that variable. Now if we were to get back to this code after a long time, it would be extremely clear what this parameter represents. The technical term for what we did here is called magic numbers, and I've also covered them in detail in another quick video. But as a rule, always remember very simply, never use magic numbers. Okay, so with this we have our raycast. It's pointing forwards for this distance. But this is actually not very useful, because the raycast, this one only returns a boolean. So all this tells us is if there's something in front or not. It does not actually get us the actual object reference. So for that, let's use a different version of the raycast function. So as you can see, we've got all kinds of versions. In order to get the object reference, let's use this version right here. This one, which has an out parameter for a raycast hit. Note the out keyword here, this is important. This means that this is an output parameter, whereas the other parameters, those are all essentially inputs that you give to the function, whereas this output, this is basically a value that the function outputs. So let's use this. So we've got the origin, we've got direction, then we've got the raycast hit. In order to use it, we need to make sure to write the out keyword here. And then also very important, we need to write the type. So let's call it raycast hit. And then the name, so let's call it raycast hit. Basically what we're doing here is essentially defining a variable of this type with this name. We're defining it and giving it to the function immediately so we can use it afterwards. If you don't include the type, if you just include the name, then you get an error because this name, raycast hit, this was never defined. Alternatively, you can define it before you pass it in. So over here, you can do a raycast hit, and just like this it works because you are defining it here and using it here. But in order to make the code a bit more compact, you can just define it here in the same place where you get it. Okay, so let's use this. And with this, the function still returns just a boolean, so just hit something or not. But then we've got the raycast hit output. This will be filmed with data from the collision if we do hit something. We can inspect this to see what data it contains, so you can right-click on top of the type, and then go to definition. And up here we do see the definition for the raycast hit struct. You can see this is a structure to get information back from a raycast. You can inspect this to see all of the kinds of things that this one returns. For example, you have a vector3 point for the impact point in world space where the ray actually hit a collider. You can get the normal of the surface and so on, so you can get all kinds of things. For our use case, what we want is to identify the object that we hit, and for that we can use the transform. So this is going to be the transform of the rigid body or the collider that was hit. So let's just do a quick test. If we hit something, let's do a log on that object. So let's do an if. So if this one is true, then that means we hit something. So if so, let's do a debug.log, go inside the raycast hit, and log the transform. Okay, so like this, we should be able to see on the console if we do hit something. Let's also do an else just to be able to easily see when we hit something. So on else, let's just log an empty dash. And in our game, in order to make sure that our collision is working, that we are correctly detecting it, let's just duplicate this object. But before we do, let's make this a proper prefab. If you have an object of a certain type that you want to create multiple instances of it, you should be using a prefab rather than just duplicating an object. That way with the prefab, if you make any changes to that prefab, it applies to all of the copies of that prefab. So let's first make this one a prefab. And again, since this is our first prefab, let's first make a nice folder to keep things organized. So a folder for our prefabs. And to make a game object prefab is super simple. You just click and drag directly from the hierarchy and drop it inside the folder. There you go. There's our prefab. And now let's just duplicate this. Make sure it has a different name. So it has a 1, so that's enough. With this, we should be able to see it just for testing. Let's put it just off to the side. Okay, so let's see. So here we are, and on the console we see a dash. So by default, we are not hitting anything. Okay, so that makes sense. Now if I move towards this object, and if there you go, it does identify that object. And if I stop moving, it stops identifying. Okay, great. Now if I move towards this one, and if there you go, this is the one with the name of 1, and this is the one with the name of none. All right, awesome. So just like this, we are correctly identifying what object is in front. Except we also have an issue. So if I move towards the object, then yep, it does work. But if I stop moving whilst I'm still facing that object, right now it's returning none. Now the reason for that is because of the move dir that we're using here. If we're not moving in any direction, then basically this vector will be 0, 0, 0. So we're going to be firing a raycast towards no direction at all, so obviously it's not going to hit anything. The solution to that is super simple. We just need to keep track of the last interact move direction. So let's go up here, define a field for that. So let's make a private. Let's make a vector3 and call it the last interact direction. And then down here when we have our handle interaction, so we get the movement here. Okay, that's great. So then we just check if the move direction is different from vector3.0. By the way, this is a constant, a shorthand for 0, 0, 0. So if it is not 0, then that means we are moving in some direction. So if so, let's set the last interact direction to this move direction. And basically if it is not, if move here is 0, then we are not going to modify this. So this one is only going to contain the last interact direction. And then down here, instead of using the move direction, let's just use this one. So that way, even when we stop moving, we are still going to be using the last interact direction. Okay, so with this, let's test. So here we are, and if I move towards it, yep, it works. And if I stop moving, and yep, it still works. All right, great. So we can move towards it, point towards a certain object, and then, yep, it still works. Okay, great. Now let's actually interact with this counter. And to do that, let's make a class for the counters themselves. So let's make a new script, a new C# script. Let's call it the same name, so clear counter. Okay, there's our script. Now, very importantly, for attaching the script, remember that we have 2 instances of our prefab. If you just select it in the hierarchy and you just drag it on there, if you do that, then you're not actually adding this script to the prefab itself, you're only adding it to this specific instance of that prefab. So if you look at this one, yep, it has a script, but this other one, which is a copy of the same prefab, this one does not have it. Also over here on the inspector, you can see the little script icon has a nice little plus. That means it is something that you are adding on top of the prefab. So that means this script is not present on the base prefab. Basically, this is not what we want. We don't want just this object to have this script. We want all instances of this prefab to have this script. So instead, let's get rid of this one from here. We want to modify the prefab itself. So one way to do that is to select the prefab on the project window. So here it is, the actual prefab. And now we can drag the script on there. So that works. Or another alternative is select the prefab in the hierarchy. And on the inspector over here, we see a nice button to open the prefab. And if we actually go into scene view, then we can see what that does. So with the object selected, so this is an instance of that prefab. But if we click on open, then essentially we are opening and we are working inside the prefab. So now if we make sure to add our script, and let's go back outside this prefab. So on the top left corner over here, we can see where we are. So we were inside our scene and then we are inside the clear counter prefab. So if we click on the scenes, we can go back. Now it tells us that we made some changes to the prefab, so let's save them. And yep, we added that script and we can see both instances of the prefab, they both have the same script. And we can see on there on the icon that this is not an override. This is an actual script added on the base prefab. So whenever working with prefabs, always make very sure that you are adding it on the right place. If you want something on the base prefab, make sure you either add it on the prefab itself, or go inside the prefab by double clicking on it, or select an instance in there and open to go inside the prefab. So always keep in mind differences between a prefab and an instance of a prefab. Okay, so we have our script, let's open it. And over here, let's just make one super simple function. So let's make it public because we want to call this from our player class. Let's return void and just call it interact. Okay, that's it, super simple. For now, let's just do a debug.log and just say interact. Okay, so that's it. And now over here on the player, when we have our handle interactions function, so we interact, we do our raycast, and we find out if we hit something. So when we do, the first thing that we should do is identify what this transform is. So is this something just like a dumb cube, or is it an actual counter? Now when it comes to identifying things, this is another place where a lot of beginner tutorials would teach you to use the Unity tag system. So that's over here in the editor when you select any object. Over here in the inspector you can see a tag, so you can see untagged and you can add all kinds of tags. This is something that a lot of beginner tutorials teach, but Unity tags are horrible. You should never use them. I covered in more detail why that is in the advanced concepts video. The main reason is because of, well, pretty much the same thing that I mentioned a while ago when we were handling animator parameters. So we were doing this and I talked about how this one takes a string and how strings are a horrible way for identifying objects. They are very brittle, very error prone, it's very easy to make mistakes. And tags have the exact same problems because tags are strings. So we do not want to use tags to identify objects. Instead, over here on the player script, let's use a different method for identifying objects. And the best way to do that is to simply get our counter component. So we have our transform, and then from inside that transform, we can call the function try_get_component. This one then takes the type of component. And again, note how this is an out parameter. So let's put out, and we want to test if this is of type clear counter. So clear counter, and call it clear counter. And this one basically does the same thing as a raycast. So it returns a boolean, so either true or false. So if this one is true, then that means that object has that component. So over here we know has clear counter. By the way, if you're not familiar with try_get_component, this is pretty much the same thing as the regular get component, except it automatically handles the null check for you. So if we just do this, it's exactly the same thing as this. So you do an if, raycast it, let's access the transform, get component. Component of type clear counter. And actually this one is not inside an if, but let's store this. Clear counter equals this. Then you do if this one is not null, then we know has a clear counter. So basically what we have up here is the exact same thing that we have down here. So just using try get component, it's just a bit more compact and I find much easier to read than to always get the component and test if it is not null. Over here we just have one function with a nice out parameter and everything works perfectly. So that's the try get component. I much prefer that method, so let's use that. By the way, on the try get component, over here you can see it has a type inside some angled brackets. Basically these are called C# generics. These are an extremely powerful C# tool. I have a dedicated video on them and I've used them in tons of videos. Definitely go ahead and learn about them. Basically this lets you write code that works with many classes, not just one specific type. In this case, the try get component can work with any type of component. So it can be Unity built-in components or it can be components that you made yourself. Then if it finds a type, it returns true. So for right now, it's not strictly necessary to know the specifics about how C# generics work, but definitely make sure you add that video to your queue and watch it afterwards. C# generics are an extremely useful C# feature. Okay, so we do this, and basically if we are inside of here, then we know this object has a clear counter, and we have our clear counter reference. So over here, it's super simple. Let's just call the interact function. Alright, so that's really it. Let's just get rid of the else. We no longer want that log, so we should be able to see a log whenever we call our interact in a counter. Alright, so here we are, and if I move around, okay, that's good. Over here the console is empty, alright. Now if I move towards the counter, yep, there you go, I'm interacting with it. And if I move towards this one, yep, there you go, interacting. Alright, great, so with this we are correctly identifying the object and interacting with it. Now let's just do one final thing. Over here we are doing a raycast to find the counter. And right now we are doing a raycast towards any object that has any kind of physics collider. So maybe that's our counter, or maybe it's just a random wall. For example, if we had an invisible wall in front of our counter, then this code would not work. That's because this raycast and this raycast hit, it only returns the very first object that it does hit. So if the counter was behind a wall, then the raycast hit object here would be a reference to that wall object. Perhaps that's what you want, or perhaps not. In that scenario, one thing you can do is instead of using raycast, you can use the function raycastAll. And difference for this one is instead of returning just a boolean, just true or false, instead it returns an array of all of the objects that it hit with that raycast. Then you could cycle through them and identify the object. So that's one approach. Or another option is over here on the raycast. If we look at these function versions, we can see that some of them has what it's called a layer mask. Basically, you can set a certain game object to a specific layer, and then if you use a layer mask, then you can make sure this raycast will only hit objects within that layer. Anything not on that layer will be ignored for that raycast. This is super useful, so let's learn how it works. For a layer mask, we can go up here and define a type of layer mask. So let's make another serialized field. Private, let's make it of type layer mask. Let's call it the counters layer mask. Okay, so we have this, and then down here when we have our raycast, let's use it. So let's find the function that matches up these parameters with the layer mask. So here it is, we have the origin, then we have the direction, the raycast hit, the max distance, and then finally we have our layer mask. So let's use our counters layer mask. Okay, great. Now back in the editor, let's select our player game object, and yep, there we see our field of type layer mask. And you can see how we can select all kinds of layers. And how we set these layers to an object is, let's just select our clear counter. Although again, we want to make sure that this change applies to all counters, not just this one specific instance. So let's go inside the prefab. And over here, we've got a field for our layer. And you can see we've got a bunch of default layers. And then we can add some more. So let's add some layers. And over here, let's go to the first empty one. And let's call it counters. Okay, we've added the layer. So let's go back, select our object. And now on the layer, let's put it on the counters. Now it asks you if you want to modify the layer for all child objects. Now, since we made sure to keep the logic and physics components only on the parent object, let's just modify this one and leave the other ones on the default. So let's just modify this object only. Okay, so with that, our counter is now on the counters layer. Let's leave the prefab, make sure to save it. Okay, great. And now if we go back into the player and over here on the counters layer mask, yep, we do see the counters layer. So let's just click the selected. By the way, this drop-down menu, you can actually select multiple. So you can select all kinds of layers. So this is multi-select, but we only want the counters, so only like this. And just like this, if we do test, and now if I move towards it, and if there you go, got the nice interact on both of them. So everything still works exactly the same, but now if we had another physics collider in front of it, it would still work because we're using a layer mask to only raycast against counter objects. Alright, great. Now I should point out another way to work with layers is with something called a bit mask. That's a bit more advanced. Usually the layer mask is much easier to follow, but if you want to learn about bitmask, go ahead and watch that video. And also another quick note, in this game we're only going to interact with one single object type. It's only going to be a counter, even though we're going to have multiple types of counters. But for games where you want to interact with multiple objects, like for example having an interact action to talk with an NPC, another one to open a door or push a button, for those kinds of multiple interactions, to build a system like that, make sure you look into my How to Interact with Objects video. It covers how to do all of that, how to interact with all kinds of objects. It's all based on C# interface, which we're actually going to use in a few lectures, and also have a dedicated video on that topic. So keep following this course, but then make sure to watch those videos, add them to your watch list, and make sure you do watch them. Watch that How to Interact video. It is something that is necessary in so many games, and most tutorials don't actually teach you the correct way of doing it. Anyway, so back in our game, we are correctly identifying and interacting with each counter. But obviously we don't want to interact automatically just like this. Instead, we want to press a nice button to interact, so that means we're going to need to create an interact input action. So let's do all of that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create a proper interact input action, and in doing so we're also going to learn about a very powerful C# feature called events. Okay, so here we have our game, so we have the player, and if we move towards the counter, yep, we are correctly identifying it and interacting with it. Except of course we don't want the interaction to happen automatically, it should be on a player input. So let's make our interact action. Let's go inside our player input action, so let's double click on it. And let's make a brand new action. So we've got the move, and now we're going to have another one, so let's click on the plus icon. For this one, let's call it interact. And for this one, action type, we do want it to be a button. Okay, great. Then on the default binding, let's go into path, let's listen, and by default, let's bind it to the E key, just like so many games. So let's go ahead, select this one, and once again, let's make sure to save the asset and let the C# class be generated. Okay. Now over here in our game input script, in order to listen, that is very simple. So we go inside the player input actions, then inside the player action map, and then we can find the interact action. And then over here, we can see a whole bunch of events that we can interact with. We've got these three: cancel, performed, and started. These are the three phases of every input. Again, I cover these stages in detail in the input system video. The important thing is that these are C# events, which I also covered in another dedicated video. Essentially, they are a way for how you can write code to then get notified when something happens, rather than running code on every single update constantly testing something. For example, over here on the movement, movement is a pretty constant action, so it does make sense to ask the input on every single update if any movement is pressed. But for an action like the interact, the player is only going to press that, say, once every 5 seconds, so it makes no sense to constantly check for that action on every single update. Instead, we just want to be notified when that action is triggered, and that is exactly what an event does. Again, watch the dedicated video to learn all about C# events in detail. They are insanely powerful, and we will be using them more and more as we go through this course. For now, here are the absolute basics. Events have publishers and subscribers. The publisher creates and fires the event when something happens, and the subscriber listens to that event and gets the listening function called when the event is fired. Now on the generated C# class, we've got these three events. The one that we want for this case is the performed event. So let's go into this one, and basically we want to add a listener to that event, and we can subscribe to that by doing plus equals, so this assigns a listener to that event. And now Visual Studio has a nice shortcut, so if we press on tab, yep, there you go, it automatically creates the function. Now if you're not using Visual Studio, you can just manually write this function. The only thing you need to make sure is that the function signature perfectly matches the event signature. As usual, we can inspect the event, so we can right click on it and go to definition. And yep, here is the definition. And you can see that this is an event of type action with a callback context. Action is what is called a delegate. I also have a video on delegates if you want to learn more about them in detail. For now, we don't really need to worry about what is a delegate, we just need to use it. So in order to subscribe to the event, we need to make sure that this one returns void, because an action returns void, and needs to have a parameter of this type, callback context. If I erase this parameter, yep, there you go, now we have an error because the function signature does not match. So it always needs to match the exact same signature, okay? And also one more note over here, when subscribing to the event, make sure you only add the function name, meaning you do not add parentheses. We do not want to call the function, we just want to pass in the function itself as a reference. Okay, so now when the player presses the interact action, it's going to fire off this event, which in turn will call this function. So over here, let's do a debug.log just to see what this contains. For example, let's print out the callback context. Okay, so let's see. So here we are, and if I press on E, yep, there you go, I've got a nice event. Okay, great, so with this we know when the player presses a key. Now the next step is how do we get the player class, how do we get this one to know when this is performed? And the answer is we're going to do the exact same thing. We're going to make an event over here on the game input class, and the player will listen to that, which in turn the game input grabs from the input system. Again, the whole point is separating our concerns. So the player does not care about the input system, does not care about the interact action, it only wants to know when something related to interact happens. So over here, let's make that nice event. First of all, let's make it public because we want the player to access it. Then we need to add the event keyword. Next, we add the delegate type. Like I said, you can learn more about delegates in my dedicated video. You can create your own custom delegate for your event, or you can just follow the C# standard and just use the standard event handler. And this one exists inside system. So let's make sure to go up here and add using system. And this one has the event handler class. This one is pretty much the C# standard for events. As you can see, it returns void, it has an object for the sender, and an event args parameter. Like I mentioned in the events video, you are not forced to use this delegate. You can use whatever delegate you want. Like for example, you saw that the performed used an action delegate. So you can use anything you want, it's just that the event handler is the C# standard, so it's easier to follow. Unless you have a specific reason to deviate from the standard, you should probably use this one. So let's use this, and then finally for the name, usually you start the name with on and then whatever happened. So in our case, let's go with on interact action. Okay, so we have defined our event, and now for firing it, let's go down here into when we have the interact performed, and let's go into the event, and for firing it, it's pretty much exactly the same thing as calling a regular function, so we just call it with parentheses. Then usually for the object sender, this is a reference to whoever is sending this event, so usually the this keyword. And then for the event args, this is in case you want to send some arguments with the event. In our case, we don't really need to send any extra data for this one, just firing the event is going to be enough. So for that, we can use the constant event args.empty. Okay, so that's it. With this, we are firing an event. Except just like this, we're actually going to have one potential error. If we have no subscribers, no listeners to this event, then essentially this field will be null, so this one over here is going to trigger a null reference exception. Let's do a quick test just to see this happening. So here, if I press on E, yep, there you go, we have a null reference exception. So when working with events, you need to first test if there are any listeners, and only then do you actually trigger the event. So you do if this one is not null. If it is not null, that means there are some subscribers, so we can fire the event. So like this, it will work, but there's an even more compact way to do this, which is perfect for events. So instead of this, we've got our onInteract action, then we can add a question mark. This is called the null conditional operator. Basically, the code is going to execute from left to right. And then when it gets to this question mark, it's going to evaluate the left side. And if it is null, then the execution will stop right here on the question mark and will not throw any errors. Whereas if this one is not null, then it continues executing to the right. Except with this syntax, we have an error. We cannot put parentheses directly after the question mark, but what we can do is simply just call invoke, and that does the exact same thing, that calls a function. So what we have here is exactly the same thing that we had previously. So what we have over here and over here, these are the exact same thing. It's just this one is much more compact, and especially for events, this one is super useful. Okay, so with this, we are correctly firing for our event. Now let's actually listen to it. So let's go over here into the player class, and let's listen to our event. Let's do it on a private void start, make it on start and not on awake. This is a very important rule, which I'm actually going to cover in detail in the next lecture. But for now, just make sure to listen on start and not on awake. So over here, we access the game input. Then let's access the onInteract action event. And as usual, let's listen to it. So let's use press tab to listen to it. So it is exactly over here that we want to run our interact code. So let's go down into the handle interaction code that we had previously, so this one. So let's copy paste all of this code, put it up here. So we get the interaction, go into the object and trigger the interact. Now obviously code duplication is a big no-no. So we're only duplicating our code just for a quick test, just to make sure it works. Once again, refactoring is super useful, so we're going to refactor this code to get rid of code duplication in the next lecture. But for now, we just want to test to make sure that this does work. So let's just remove the interact over here from the handle interactions. So the only interact function being called is over here when we have our actual input. So let's test and see if we can press to interact with the counter. Alright, so here we are, and as I move around, if I approach the counter, yep, there you go, we no longer have the automated interaction. And now if I'm facing the counter and I press the interact key, yep, there you go, here we have our nice interaction. Alright, awesome, so I can approach, I can interact and do whatever I want. Alright, so here we learned about C# events. These are super powerful, so if this is the first time you're hearing about them, then you've just added an awesome new tool to your toolbox. Definitely make sure you watch my dedicated video to learn about them in more detail. Events are super useful. The next thing we're going to need is just a visual to highlight the current selected counter, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add a visual to our selected counter, and in doing so we're also going to learn about the very useful singleton pattern. Okay, so over here we already have the logic to identify the counter in front of the player, and we can interact with it. However, whilst the logic works, there is no visual indicator at all, so let's add that. Now, as usual, the super quick and dirty way of doing it would be pretty simple. Over here on the player script, we could just directly enable a visual mesh on the target counter. So down here on the handle interaction, when we have this, over here we could tell the clear counter to enable some kind of visual. Technically that would work, but that would be some pretty dirty code. We would basically be making the player responsible for enabling some kind of visual, which would mean that we were mixing logic with visuals. Again, we always want to try separating the logic from the visuals as much as possible to keep our code nice and organized, so instead of doing the quick and dirty route, let's do it properly. Back in the editor, let's create a brand new C# script. Call this the selected counter visual. And now let's go into the prefab. Again, let's go inside it, so let's select the clear counter on the hierarchy, then on the inspector, let's open up, go inside the prefab. And now let's select the visual inside it, and let's duplicate this, so you can press Ctrl D to duplicate it. Let's name this one selected, and then inside there's a visual with a mesh filter and a mesh render. So over here, let's swap out the material. So let's click on the circle icon, and now included in the assets is this material, counter selected. So it's all the way, yep, up here, the counter selected. Basically, it's just a solid white color with a low alpha. So on the kitchen counter inside the select game object, let's make sure to use this one. With this, we have kind of like a ghost visual. So if we enable and disable this game object, we can see the difference. Also, let's do one tiny thing, which is right now we duplicated the actual visual, meaning that these objects are exactly the same, they have the exact same size, and when that happens, you might end up with some rendering bugs. If two meshes are on the exact same position, you might sometimes see the colors constantly flip back and forth. So in order to make sure that doesn't happen, let's make this one deselected a tiny bit bigger. So over here with the selected game object selected, on the inspector over here we've got the scale, and also we've got this nice little button here. If it's like this, then we can modify each proportion differently from one another. Whereas if we click, now these are all linked. So now modifying one will modify all of them, so let's put this on 1.01. Meaning this one is going to be literally just 1% bigger. So that's enough of a difference to make sure we don't have any rendering bugs. And by default, let's also start with the visual hidden. So let's do that not on the parent select game object, but rather on the kitchen counter inside of it. Let's make sure to disable this game object. By the way, the quick shortcut is Shift, Alt, and A. You can enable or disable the object, very useful. So let's start with this one disabled so that it's hidden. And basically the goal is that when this counter is selected, we're going to enable it and show this visual, and when it's not selected, we're going to disable it. Okay, so over here on the selected, let's add the script that we made, so the selected counter visual. Alright, so let's open it. Now here, first thing we need to know is which counter is selected. Meaning we need to know which counter the player is currently looking at. So let's go over here onto the player script, and let's basically just do some simple logic to keep track of the selected counter. So over here, let's make a field, so a private. Let's make it of type clear counter, and just call it the selected counter. Then down here we have our handle interactions logic. Okay, so we do all of this. We try to find a counter in front, and if we do find it, then we have it here. So here, let's just check if it's different. So if this clear counter, if the one in front is different from the current selected, then let's set the selected to this one. And let's also make sure to essentially unselect. So we want to make sure to set this one to null when there's nothing in front of the player. So if the raycast does not hit anything, then there's nothing in front of the player. So let's set the selected counter back into null. And also, if there is something, but that something does not have the clear counter script, then it's also not a counter. So over here, let's also do an else selected counter equals null. So basically, if there's a counter in front of the player, then it's going to set it. If not, then it's going to be null. Let's just do a simple debug.log to check on the selected counter, okay? And also, just briefly, now that we've made this selected counter logic, actually up here when we have our interact action, like we saw we were previously copying some duplicated code, but now we no longer need this since we already know the selected counter. So over here when we've got the interact action, let's just check if we do have a selected counter. So if it is not null, if so, then we go there and we call the interact function. So that's it, we no longer need all of this logic. Okay, that's great, so let's test. Back in the editor, let's go back into scenes, let's make sure to save the prefab. Make sure the script was attached, save it, and let's hit on play. And right now, if I'm down here, yep, there you go, we've got null. And as I approach, yep, there you go, that one is the clear counter. And if I move towards this one, yep, it's that one. Okay, so basically we are keeping track of the currently selected counter. Now basically we just need to notify the visual whenever this one changes. So when this one is pointing at that one, or pointing at null, or pointing at that one, we need to know when that happens. And for that, we basically have two options. Now, one option is pretty much what I mentioned a while ago, which is over here we have the selected counter, so we can run some kind of logic on the selected counter. We can do that over here on the player. Then perhaps over here the counter would fire off some kind of event saying it has been selected, and then the counter visual would listen to that event and update itself. Now, that approach would be useful if we wanted to add some kind of logic on the clear counter while selected, and that approach would also have the benefit where the visual counter would only listen to events on its own counter. So that's one approach, pretty much a very direct approach. But another one is very simple. The player would simply fire off an event whenever the selected counter changes, and then all of the counter visuals would listen to that event, then they would identify if the event relates to that counter, and if so, update their state. Now the benefit of this approach is that the logic doesn't get bothered with any selection logic. So over here the clear counter script never really knows if it's selected or not, and that's a good thing because it doesn't need to know. Although the potential con with that approach is that all of the selected counter visuals are all going to listen to the same event. So both approaches have pros and cons. Here let's go with the second approach where all the counters listen to a player event. The potential performance con doesn't really matter on a game of this scale. We're only going to have about a dozen counters, so even if 11 of them are just wasting on listening to the event, it's really not going to matter. And going with this approach will actually help us learn about the singleton pattern, which is extremely useful. So first let's go over here onto the player class and let's make the event that we're going to fire. So as usual, let's make it public so we can access it. Let's make it an event. And as usual, let's also use the standard event handler. Let's make sure to add using system. So here Visual Studio adds it automatically. Okay. And let's call this on selected counter changed. Also, this is a great moment to learn about the event args. This is how you can extend a C# event in order to pass in some more data. So how you do it by following the C# standard is very simple. We just create a class. So over here, let's make a public class. Then for the name, usually you include the name of the event with event args at the end. So in this case, on selected counter changed and then event args. Then on this class, we make it extend event args. And finally, inside the class, we add whatever data we want. Like for example, we want the current selected counter, so let's make a public clear counter and put the selected counter. Okay, so we have this nice event args with a bunch of extra data, and then over here on the event handler, we use the version that takes a generic and we pass in our event args. Again, I covered the generics in more detail in a separate video. Definitely go watch that one if you haven't seen it yet. C# generics are one of C#'s most powerful features. Okay, great, so we now have our nice event. Now let's fire it off. So let's go down here to when we're modifying the selected counter. So here it is, we've got all of these ones. So when we modify, let's fire off the event. So we go into this event, and as usual, let's use the question mark and then call invoke. Then for the object sender, it's going to be this, so pretty much the standard. And then for our custom event args, let's construct an object of that type. So construct a new object. And then inside we pass in the selected counter and we set it to this selected counter. Now, don't be confused by the fact that we're using the exact same name. If you actually mouse over the cursor, Visual Studio actually helps you by telling you which object refers to this. So with the cursor here, note how all of these are highlighted, but this one is not highlighted. That's because this is the field inside the onSelected counter changed event args, whereas this one out here is the object that we're referencing in here. So even though these two have the exact same name, here we're accessing the field inside of that, and we're assigning it to the reference that we have down here. Okay, so that's really it. We're firing off the event when the selected changes, and we're passing it in. And let's also make sure to do it over here, so let's copy and paste some code, and there you go, just like this. Except, of course, we can already see a bunch of code duplication. Usually that means it's time to refactor, so let's do that pretty quickly. Let's go down and make a brand new function. So let's make a private void. Let's call it setSelectedCounter. And we're going to receive a clear counter for the selected counter. Then over here we just set this.selectedCounter, so we're modifying the member variable with the one that we receive on the parameter. And then let's also fire off the event. So let's copy paste the event, just like this, the exact same thing. Okay, so that's it. And now up there, instead of code duplication, we just do this. So over here we set the clear counter, just call the function, pass in that one, and get rid of this. And on that one, just pass in null, just like this, get rid of all of this. And here the same thing, just pass in null. Alright, so with this our code is much cleaner and everything still works exactly the same. So here we have everything done on the player side. Let's just get rid of our log, we no longer need this. So we're still handling the selected counter logic, and then down here we're firing off the event. Now all we need to do is go over here into the selected counter visual script. And here what we want to do is to listen to that event. In order to do that, we need a reference to the player object. Now, so far when we've been listening to events, like for example on the player class, up here we were listening to some events on the game input, so there you go, the onInteract action. So for the game input reference, we just added it as a serialized field. We did this and then we dragged the reference directly. And technically we could do the same thing over here on the selected counter visual, but we're going to have like a dozen counters in our map, so it would be pretty tedious to drag and drop the player reference to every single one of them. So instead of using a serialized field, another approach is to use the singleton pattern. This one is an extremely useful programming pattern. It's very useful for things where you only have one instance of something. In this case, we're making this game single player, so we're only ever going to have a single player. By the way, here's one obvious quick note. Like I mentioned in the beginning of this course, after this video, there's going to be another one converting this game into multiplayer, and in that case, we will have multiple player instances. But this is also an excellent reminder of how refactoring code is perfectly fine. For right now, for this game, it is intended as single player, so for now we're going to use the singleton pattern. Then in the future, when we convert this to multiplayer, we will simply refactor that logic. Again, don't be afraid of refactoring code. It's a perfectly natural part of programming and game development. Okay, so let's implement the singleton pattern. This is actually super simple. The name sounds intimidating, but it really is very simple. Over here on the player script, let's make a public field. This one, let's make it static. If you don't know static, basically it means that this field belongs to the player class itself and not to any instance of a player. So for example, if you had 100 players, you would have 100 instances of move speed, you would have one for each player, but there would only be a single static field because this static field belongs to the class itself and not to any instance. So let's make a field of type player, and then for the name, the convention is to call it instance. And the reason why I'm using Pascal case here, so capitalized in the beginning, the reason for that is because this is actually not going to be a field, but instead it's going to be a property. Remember the naming rules that we covered in the beginning of this course. It's very important you follow your naming rules. Always be consistent so your code is easier to understand. So with that said, since this is the first time we're using a property, let me quickly explain what it is. Basically, it's the exact same thing as a regular variable, except you can add some logic when getting and setting that field. So here let me write some quick code just to show the difference between a property and a regular field. So for a regular field, you would call this maybe instance field, something like this. So this is a regular field. Then you would have some kind of public static return a player and call it get instance field. Then over here you would return the instance field. And then maybe another public static void set instance field, where you receive a player for the instance field. And you would set the player.instance field into this instance field. So this is how you do this logic with fields. And now with properties, you would do public static player, then call it instance. Then on the property itself, you open up the curly brackets. Inside the property, you put a get, then you return something. So for that something, usually a property has a field underneath it. So you'd have a private static player for the instance. That's a different name from this one. On the get, you would return that. And on the set, you would set the instance equals the value. If you're confused here, don't worry. Basically, I'm just repeating just so you can see the difference. Here we have a field with a get and a set function, so regular functions. And up here we have a property, and inside the property itself has a get and set functions, which can also do some logic, so you can do some logic in between, or you can just return the underlying value. So basically using a property is pretty much the exact same thing as using a separate get and set function. Also, one more bonus thing, which is that C# is smart enough to automatically create the underlying field for a certain property. So if you just want to do a get and a set, then you don't need to define all this. You can just define a property, and then inside you can just do get and set. And there you go, this code here works the exact same thing as we had previously, which in turn is the exact same thing as all the code we have here with a getter and a setter function. So here it is, a valid functional C# property. Now I have to say that personally I very rarely use properties. In fact, the only place where I use them is over here on the singleton pattern. For everything else, I normally use regular fields with get and set functions. Personally, that's just the way that I like to code, but that's really just personal preference. So if you do like to use properties, then go ahead and use them. Anyway, so the reason why I like using a property specifically for the singleton pattern is because the implicit implementation allows you to do something really nice. Again, remember the goal with clean code. We want to minimize complexity, and the best way to do that is minimize access. Here, if we set this property and we set it as public, then that means that any other class can both get and set, so anyone else can have both read and write access. So we have the exact same problems that I warned you about when I spoke about why you should not make everything public. And of course, if we make this private, then at that point we kind of lose the purpose of our singleton, since no one else will be able to access this. Basically, we want to be able to access this reference from classes outside of this one, we just don't want those classes to also have write access. Now thankfully, properties have an excellent thing, which is you can define accessors for here both the get and the set. So we can make the property itself public, which means by default both of these will be public, but then we can also add the accessor over here private, which in turn means that the get will be public, so any other class can get this, but private means that only this class can set it. This way we have the exact level of accessibility that we want. This is the reason why for this specific use case properties are very useful. With just this one line of code, we already have our instance with the perfect level of accessibility. So now that we have this field, to set it, let's make a simple awake. So let's go over here, private void awake, and on awake we just set instance equals this. However, remember that a key point of the singleton pattern is you only have a single instance of something. So in this case we should never have more than one player. If we do, then something went wrong. So we can add a nice safety feature here. Let's just check if instance, if it is not null, meaning it has already been set to something. If so, then that's an error, something bad happened. So let's do a debug.log error, because this should never happen. So let's say there is more than one player instance. This way we have a nice safety check just in case something goes wrong. Alright, so that's really it for the singleton pattern. We just define a property with a public get and a private set, and on awake we just set the instance. That's it. As you can see, it's super simple. And now for the really useful part. Over here on the selected counter visual, now we can access the singleton instance in a super easy way. Let's make a private void start, and on start we just access the player class, and from the class we can access the static instance, so we can access the singleton, and now we can listen to the onSelected counter event. And over here by default, Visual Studio gives this function the name of the event and also the property. This isn't a very descriptive name, so I like to rename this, so Ctrl-RR, and just rename the instance here. Instead of instance, let's rename it to player. Okay, great. So over here we can listen to this event. However, here is yet another extremely important thing. Note how I made this on start. That is very important. If you do this over here on awake instead of start, and over here on the player, you're also setting the instance on awake. If you do that, basically there is a chance that this code will run before this code. And if that happens, well then this one, the player instance, has not been set yet, so this will be null and it will throw a null reference exception. Now whether this happens or not is actually somewhat random. It depends on the order in which Unity decides to run both these scripts. If Unity decides to run the player first and this one second, if that happens then there's no problem, but if Unity decides to run this first and then this one, then we have a problem. Let me do a quick test and see if in my case it triggers that error. And yep, in my case it did trigger that error, so here we have a null reference exception, and yep, it is being fired on this line. Now, one solution to this problem is you can tell Unity specifically which order the script should run in. So you can go up here into Edit, then go into the project settings. Then on the left side, you've got something called the script execution order. And basically over here you can set the order in which all of these scripts run. So if you were to make the player script run before the default time, that would make sure that even though both these scripts are on awake, this one would run before this one. So that would fix that problem. However, you should really only use this approach in the last case possible where there really is no other way. In this case, we do have another better way. Personally, I have a very simple rule that I like to follow that helps solve this issue. As you know, Unity has both an awake and a start. And all of the awakes on all the objects will all run before all of these starts. So the simple rule that I follow is that I use awake for the initialization of that script, and for any external reference, for that I use it on start. So in this case, for initializing the player and setting the instance, that relates to the initialization of the player, so let's do it on awake. Whereas over here on the visual, since here we're going to access the player, which is an external reference, for this one, instead of doing it on awake, let's do it on start. This way we are guaranteed to make sure that this instance has been set. Okay, so with all of that, here we have our instance, so that works great, and we have our event, so that's great. Then here we have our event, and inside we've got our event args, so we can go inside the event args object, and inside we have our selected counter. So all we need to do is just compare which counter this visual belongs to. So let's actually make a field up here. So as usual, let's make a serialized field of type clear counter. So we have this one, and before we go into the editor, just make sure it compiles. Let's comment this out. So now let's go back into the editor. And over here, let's drag the reference. But again, remember, we're working with a prefab. So let's click on open to go inside the prefab. And now whilst inside it, let's select the selected game object and just drag the clear counter reference. Okay, great. Let's go back outside and save the changes. All right. So now here in the code, it's actually very simple. So we just do an if the selected counter matches this clear counter. If so, then we want to show this visual. If not, we want to hide it. So let's also add a reference for that visual. So let's add another serialized field of type game object for the visual game object. Then back in the editor, again, let's go inside the prefab, and on the select, let's drag the child kitchen counter. So drag that one, that is the visual game object. Okay, let's go back, save. And back in the code here, let's make some simple show and hide functions. So private void show and a private void hide. And now on the show, just going to visual game object and call set active. So this enables or disables the game object. So for show, let's set it to true. And for hiding, let's set it back into false. Okay, so now it's super simple. If the selected counter is this counter, then let's show the visual. If it is not, then let's hide the visual. All right, that's it, super simple. Let's test. So here we are, and if I approach that counter, yep, there you go, look at that, the nice selected visual. And if I go into this one, yep, there you go, I can see it. All right, great. So here we added a really nice visual to our selected counter, and more importantly, we learned about the super useful singleton pattern, as well as learning about C# properties, and a very helpful rule for how to avoid code timing issues. So this was a really detailed, really important lecture. If you're feeling confused about anything, go ahead, watch it again, or just post a question in the comments and I'll do my best to help. So with all of this is all great. We have the selected counter and we can see which one is actually being selected. Then by pressing a button, we can actually interact with it. So I can move and interact with any of these counters. But right now, just interacting with them doesn't really do anything. So the next thing we need is to create some proper objects for all of our ingredients, so we can later pick them up and drop them on counters. So let's begin doing that in the next lecture. Hey again, quick intermission. You're past the 15 lecture mark, so congratulations. Looking at my regular core stats, it seems about 80% of people give up by this point, so great job with sticking with it. The difficulty and complexity is increasing over the lectures, so I just want to check in to make sure you're understanding everything. Remember to post in the comments if you need extra clarification on anything, and I'll do my best to answer. Also check the website to see what questions others have asked. And of course, remember this is your learning journey. You're not competing with anyone but yourself. So take your time, rewatch some lectures if you need to, just focus on learning. Okay, let's go to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to create the kitchen objects like the various ingredients. Okay, so far we have our player, we can walk around, I can approach each of these counters, and I can interact with it. Now the next goal is to create objects the player can pick up and drop when interacting with a clear counter. So let's begin by making the actual objects. So let's create a new empty game object, call this one the tomato. Then again, as usual, let's separate the visual. So in the included assets, let's go inside of it. Then we've got the prefab visuals, and we've got the kitchen objects visuals. And inside we've got all of the ingredients. So let's just find the tomato visual and drag it as a child of the tomato. And again, as usual, make sure to put on position, local position 0, 0, 0. And for the main one, let's put it on a Y of 0 and just push it a little bit off to the side just so we can see. Okay, great. Now, this one is obviously not going to exist over here in our world. Instead, we're going to spawn it. So let's make it a prefab. Let's just drag it over here into our prefabs. Okay, there it is. Let's delete it from our scene. And actually on our prefabs, let's make a nice folder to keep things nicely separated. So inside the prefabs, let's make a subfolder. Call it the kitchen objects. Let's put the tomato inside of it. And let's also make another folder for the counters. And let's put the clear counter inside of it. Okay, so everything is nicely organized. All right. Now that we have this, let's go inside our clear counter script. And over here, let's add a simple reference to our prefab. So let's make of type transform, call it the tomato prefab. By the way, here you could make this prefab reference of type game object. Which type you use in this scenario is pretty interchangeable. I talked about those differences in another video. So when using prefabs, using them as transforms or game objects, that's pretty much personal preference. And personally, I just prefer to use them as transforms. Okay, so we have this. Let's just make this a serialized field so we can set it in the editor. And over here in the editor, let's open up, go inside the counter prefab and just drag the tomato reference. Okay, great. Let's go back outside, save. Now back in the code here, when the player interacts with it, let's just spawn it. So let's call instantiate, pass in the tomato prefab. And now here is a good question, which is where exactly do we spawn this? We don't want to spawn on this counter's origin. Remember that the counter, the way we set it up, the origin on the actual object is over there on the bottom. We don't want to spawn the tomato inside the mesh. That would not make sense. Instead, what we want is to spawn up here. So the next question is, okay, so how do we get this point on top of the counter? One approach would be to use a vector3 directly in the code. That would work, but not very usable. So a more designer-friendly method is to simply use an empty game object as a target. So on the counter, let's first go inside our prefab. And over here, let's create an empty game object inside of it. Let's call this the counter top point. Let's make sure to leave this one as empty, so no components, just a transform. And now let's just position it, so let's lift it up by just about enough, so let's make sure we see. So there you go, just about that. So let's put it on position, a Y of 1.3. Alright, so this point is going to be our spawn point. Let's make sure to save the prefab. Then back in the code here, let's add a reference to our point. And for reference, let's also use a transform reference. Call it the counter top point. Okay, now let's just comment this line just so the code compiles so we can drag the reference. Back in the editor, inside the prefab, let's just drag the countertop point reference. Okay, great. So now here, when we call instantiate, let's instantiate it inside the countertop point. So this will spawn the object, so let's say the transform for the tomato transform. And then we go inside this one, and let's just make sure we position it correctly. So let's put it on a local position of vector3.0. So this will put the object exactly on top of our countertop point. Also here, very important, don't make a mistake. Make sure you're modifying the local position and not the global position. Okay, so with this, let's test. Over here in the editor, let's go back, save our prefab, and hit on play. So here we are, let's approach the counter and interact with it. And yep, there you go, it does work. The tomato was indeed spawned. All right, awesome. Okay, so with this, we have pretty much our basics working. We can move up to a counter, we can interact with it and spawn an object. But now let's say that we want to spawn a different object. So let's say now we want to spawn some cheese. First of all, let's make the actual object. So on the tomato, let's press Ctrl D to duplicate this one. Let's rename this to the cheese block and let's go inside of it. Now in here, instead of the tomato visual, let's drag, here it is, the cheese block visual. So let's use this one instead. Okay, there's our nice visual. Let's make sure to save the prefab and go back out. And now let's say that we want this one to spawn a tomato and this one on the left to spawn some cheese. So let's override the prefab and over here drag the cheese block. And now if we hit on play, can go up to this one and yep, there's a tomato, go up to this one and yep, there's some cheese. Okay, so it all looks great. But now let's say we want to know what object we just spawned. Like what object is on top of this spawn transform. Just like this in the code, all we have is a transform reference. So with this, the only way to know what type we spawned would be if we had different prefabs for every single object. Then we could compare them one by one and see which one this matches. But then let's say, what if we wanted an actual string for the object? Well, then we would need to add tons of fields for all these strings for all of the objects. Then what about an icon for each type? Once again, we would need tons of fields, each one for each icon. But if we did it just like that with a bunch of lists, then they would be separated. That's not very good. we should have a proper way of defining our object types and all the data related to them. So this is exactly where scriptable objects come in. These are objects you can create in your project files, which are perfect for anything where you have multiple instances of a type. Like for example, multiple weapons, multiple armors, multiple recipes, or maybe multiple ingredients. As usual, I have a dedicated video on scriptable objects. They are super useful, definitely watch that for more detail. Over here, let's just use them. So the first thing we're going to need is to actually define the type, and we do that in a C# script. So in our scripts folder, let's create a new C# script. Call this the kitchen object SO. Now personally, SO is just what I like to append to my scriptable object definitions, just to make it very clear that it's a scriptable object. However, this is not a requirement, it's just a naming rule that I like to follow. And we're calling this kitchen object because we're going to use this to define any kitchen object we want to interact with. So that's going to be our ingredients, like for example the tomato and cheese, but also things like a plate, and then potentially you could implement things like a frying pan or frying extinguisher or anything like that. So this is going to represent any kind of kitchen object the player can interact with. Okay, so let's make the script, and now let's open it. And over here, okay, first things first is this is not a mono behavior. Instead, let's extend scriptable object. And then technically you can have functions inside a scriptable object, but for now let's just get rid of this, so just an empty class. And over here, let's just place whatever fields we need to store whatever data we want. So like I said, first we want a prefab, so let's make a public transform for our prefab. By the way, here note how I am indeed using public. This is pretty much the one exception to the rule. I only use scriptable objects as read-only data containers, I never write to them. So since I follow that rule, I usually make the fields in the scriptable object public. That way I can access them directly without having to make a public getter. But if you want, do feel free to keep following the general rule of not making anything public. You could definitely make this just a regular serialized field and expose with a get function, that would work. Personally, I just find it simpler to make it public, since I know that as a personal rule I will never write to a scriptable object field. Okay, so we have a transform for our prefab. Let's also add a sprite for the icon sprite. And finally, let's just add a simple string for the object name. Alright, so we have our scriptable object definition. We have all of the fields for all of the data we want to store. Now, how do we actually create a scriptable object? For that, let's go up here before the class name, and we're going to add the attribute, so let's add the square brackets. And the attribute is the create asset menu. This takes some optional parameters. Again, I cover them in detail in the dedicated scriptable objects video. For now, let's just leave all the parameters as empty, just use defaults and close the attribute. Okay, so that's it. Let's save this and go back into the editor. And over here, if we go into the project window, click on the plus icon, and right up top, yep, we do see a kitchen object SO. So if we select it, yep, there you go, it creates a brand new object inside of our project files. Let's name this one tomato. And obviously, let's keep our project nice and organized, so we don't want this inside the scripts folder. Instead, let's make a proper folder, so create a new folder, call it our scriptable objects. And then inside, let's put a different folder for each type. So let's make another subfolder, call it the kitchen object SO, and let's place the tomato inside of it. Okay. Now with the tomato selected, we can look in the inspector, and we can see, yep, it does have all of the fields that we defined. Okay, great. So now we can just assign them. So this is the tomato, so let's drag the tomato prefab. For the icon sprite, let's find it. So there are sprites included in the regular assets, so here is the tomato sprite. So it's inside the assets, then inside textures, icons, and we have all the icons. And finally, for the readable name, let's just call it tomato. Alright, so that's it. Here we have a really nice scriptable object containing all the data required for our tomato. Okay, awesome. With that then, we can now go back into our clear counter script. And here, instead of entering a field for our tomato prefab, instead of this, let's store a reference of type kitchen object SO, and let's call it kitchen object SO. And then when spawning, let's go inside our scriptable object and just spawn the prefab reference. So this is going to be the kitchen object transform. Then over here in the editor, let's go inside the clear counter and let's assign the tomato kitchen object. Okay, so let's save it and test. So here we are, let's approach, hit, and yep, there you go, it still spawns the tomato. Okay, great. Now let's make another type for our cheese block. So let's create a brand new kitchen object SO, call it the cheese block. And again, let's assign, first of all, the prefab, there it is. Then for the sprite of the cheese block, and finally, this is the cheese block. Okay, so now, for example, let's go into the second one. And on the second counter, let's override and say this one spawn a cheese block. So let's test. So here we are, approach this one. Yep, there's tomato, this one, and yep, there's some cheese. Okay, great. So everything is working so far. However, the original problem that we're trying to solve, identifying the spawn prefab, we still don't have a solution for that. Basically, when we spawn a prefab, we need to know from which scriptable object this prefab came from. So essentially what I like to do is just attach some reference to the scriptable object in our prefab. However, again, remember that scriptable objects are not mono behaviors. So if I select the prefab and I try dragging the scriptable object, nope, it does not work. So what we can do is just create a new script. So let's make a brand new C# script. Let's call it kitchen object. Let's attach this to both prefabs, so both the cheese and the block, attach the same one to both of them, and let's open. And over here, very simple, let's just add a serialized field for our kitchen object. So a serialized field of type kitchen object SO for the kitchen object SO. Then let's also make a quick function to expose it. So we're going to return kitchen object SO, get kitchen object SO, and we just return the kitchen object SO. Yep, just like this. So now here in the editor for the tomato, yep, we've got the field. So let's say this one is a tomato, and the cheese block, this one is a cheese block. Now here, obviously, we need to make very sure to drag the correct reference to the right scriptable object. If you drag the wrong one, like for example over here on the cheese, you would say this one is a tomato. If you did that, then obviously you would get some very weird results. So make sure to check and double check that you drag the right references. Both over here on the prefabs, make sure they are referencing the correct scriptable object. And on the scriptable object itself, make sure they are referencing the correct prefab. Okay, so now if you go here on the clear counter, we spawn our object. Okay, great. Then on this object, we can do get component of type kitchen object, and then we can just ask it to give us the kitchen object SO. So for example, let's do a debug.log on this one. So inside, get the kitchen object SO, and then let's print out the object name. All right, so here we are. Let's interact with this one. And yep, there you go, interacted and spawned a tomato. And on this one, yep, interacted and spawned a cheese block. Okay, awesome. We spawned a transform prefab, and we identified the spawned object is indeed this type of object. Alright, so here we'll learn about one of the most powerful Unity features, scriptable objects. These are extremely useful for defining a type and then creating multiple instances of that type with whatever data we want. So that can be some ingredients like we have here, or it could be some weapons, could even be some NPC data, maybe some quest data, and so on. It really is an insanely very useful feature. Definitely go ahead and watch a dedicated video on scriptable objects. Then if you want, you can also watch some more videos where I've used scriptable objects. For example, the Minecraft crafting system using scriptable objects, or the Hydroneer crafting system, which again also uses scriptable objects. Okay, so this is done, it's working great. Now let's continue to the next lecture, where we're going to help the kitchen object know where it belongs and help each counter know what kitchen object is on top of it. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a kitchen object parent, meaning that the kitchen object will know where it is, and the counter will know if something is on it. This is important so that later on we can pick up a kitchen object from one place and drop it in another. Okay, so here we have our player. I can move towards this counter, interact with it, and yep, spawn a tomato. Then on this one, spawn some cheese. Okay, great. But I cannot do anything else. In fact, if I interact a bunch more times, really all I did was just spawn a whole bunch more cheese. So instead, I want to be able to spawn some cheese and then pick it up. So let's think about exactly what that means. We want a kitchen object to essentially be placed on a specific place. Based on the design that we're trying to implement, we're never going to have a kitchen object just randomly strewn around the world. We're not going to have tomatoes all over the floor. Instead, the objects will always need to be placed somewhere, and that somewhere can be either a counter or it can be being held by the player. So essentially that means that each kitchen object is going to have some kind of parent that it's attached to. We're going to make sure the counter knows if there is a kitchen object placed on top of it, and we're also going to make sure the kitchen object itself knows where it is. So first, let's do that logic over here on the counter. So on the clear counter script, let's keep a field for a kitchen object. So just a simple private of type kitchen object. Then when the player interacts with it, by the way, we can get rid of these debug transforms, debug logs, we no longer need them. Okay, so when the player interacts, so if the kitchen object is null, if so, then we're going to spawn it. Then when we spawn it, let's assign it. So this one equals the kitchen object get component of type kitchen object. Okay. So if that one is null, we spawn it and we assign it. And just with this, we should have